the context of the recording, today is the day that you're gonna make nominal records. So proper records, I would say, because if you're not using F sharp and OCaml, I don't think you have anonymous records. Although our language does have that. Anyway. So let's start with the AST stuff. So let's go down here. So what is a nominal record? Yeah, Nathan, pretty much. So my gut feeling is that an anonymous record is something that we can just put nominal here, a label, and that's it. Oh, my screen's not sharing? I'm so sorry for that. Sorry for that. Okay, so this is my intuition. So what do you say, Nathan?
What about
Mm-hmm.
if we start on Wikipedia?
Okay.
That's fair.
Okay, so nominal records, Wikipedia. Nominal type system, is that the one that you want?
I guess it can help us, yes.
Okay, so in computer science, a type system is a nominative type system if compatibility and equivalence of data types is determined by explicit declarations and/or the name of types. Nominal systems are used to determine if types are equivalent, as well as if a type is a subtype of another. Nominal types construct with the structural types, where comparisons are based on the structure of the types in question and do not require explicit declarations. Okay, so do we want... I don't think this is what we want then.
Hey, care to read the last one? The last one might be very interesting.
This, you mean?
No, the very last heading. Comparison.
Comparison. Nominal typing is used for preventing accidental type equivalence, which allows better type safety than structural typing. The cost is a reduced flexibility, as for example, nominal typing does not allow new supertypes to be created without modifying the existing subtypes.
That's already an answer that I was, for what I was thinking about a few minutes ago. Like, okay, why do we want that, right? Like, why do languages have that? Like, what is the big deal about it? We are implementing this just because, well, languages do? Or,
No, well, from my personal opinion, it's because records can do more than ADTs.
what do you mean by that?
Yeah, so for instance, if you have an ADT that you have like five things, like I don't know, let me do an example here.
Yeah, that's it.
So if you have a piece of ADT, and then you have ADT, and then you have a string and an int and a char and a double, like it's really convenient to add meaning to each of those things.
Yeah.
Because right now the only way that you can provide meaning is to make functions to the ADT. Like you do, I don't know, name, then you say that you're gonna receive an ADT and you're gonna return a string. So you would have to do that for every single time you want to modify the internals of this. So in order to do that, in order to avoid doing that, you create a record on it in which you can give a name to each specific thing inside.
Yeah, but Lemus, that's not about being nominal, right? That's just about a tuple and a record, or name it tuple, whatever. Like, there you have like a tuple, right? You have this product type in which the order matters,
Yeah.
right? But the thing is, as you said, they don't have a specific meaning about it, right? Like,
Yeah.
you can't, like,
Yeah, and that's something that you said too. The order matters. That sucks.
yes, the order matter. That also really sucks well, sometimes.
Yeah.
So yeah, but when you have records, It's just like tuples, but the order doesn't matter, and they have labels attached to each type, right?
Yeah. So that sounds
So
very useful.
yeah, but that's just tuples versus records. Well, so that's nothing regarding being nominal, right? For example, we already have the thing that you said. We have anonymous records. As you can, out of the thin air, just create a tuple anywhere, you can do that with records. That's what we have, the anonymous records.
Yeah.
So why do we need another type, right? Another kind of...
Well, something that I thought about it reading the comparison is that if you want to change, like I want to add a new thing to the anonymous record, you have to go to every single place that has that and add that extra thing. And with the nominal one, with the name is the same, but the internals are different.
Yeah, that's not a good point because if you have alias and you have the anonymous records, you can do that. Right?
If you have an alias, yeah, you can replicate that with an alias. You can. That is outside of the anonymous record scope, so it still sucks. My point is still remain.
Yeah.
But you're right. You can get around that problem using alias. Yeah. So tell us, Nathan, why do we need? Why would we want nominal records?
Well, that's what the comparison was saying.
No, yeah, but I wanted you to say in your words, not the Wikipedia ones.
So yeah, that's the thing. Let's suppose we have like a person, right? And it has a name and age. Okay.
Mm-hmm.
And sure, that's a person. But if that's an anonymous record, I don't have really the concept of a person in my language. I have anonymous record that has a name field, an age field, they have specific types, but that's it. It's not a person.
Yeah, it is. Yeah, I get it.
You see?
Yeah, I would say
So
that it is very useful to add meaning to that.
You
yeah,
can,
that's not all, but that's part of it, yes.
Go
you
on,
can
Market.
make an.
Hello?
I think you can make an record, but that's still. Oh, sorry. Can you hear me?
Now I can.
Yes.
Okay. So what I was saying is, I think you can just do an alias, right? But it's not changing the type. It's just giving a name for like the anonymous record.
Yeah, that's actually the best argument ever. That's actually not a problem if you have alias out.
Yeah.
But yeah, okay. So that's good. But the thing is, uh, sure, I have this thing, and we can even call it a person now that we have like type alias and shit. But let's suppose I have something like a professor, right?
Oh wait. Now I think I got. Sorry to interrupt you, but now I think I
Mhm.
got what this is trying to say. The
Uh,
fact,
yeah.
because if you have a person as a type alias and you have a dog with the same type alias, a dog is equal to a person.
Yes, you could use one instead of the
They
other,
might,
right?
they might just have the same alias, but well, if you compare them, it will be the same. Right?
Yes,
Yes.
But they
even
might
though
have
they
different
have
aliases.
different names on the alias, right?
Yes.
So yeah, the
That's fair.
whole nominal thing is the whole thing about comparison itself. Like it's only different there, right?
Yeah.
Because even if they have the same format, they will not be equal. So yeah, that's very interesting, I guess.
Yeah, that is a very good argument to have nominal stuff then. That's a very good argument.
Not to be confused with a dog.
Yeah.
That's a short way to say.
Okay, so let's think about it. So in the expression level, this is what I added there. I just added this. So what do you think, Nathan and Mageta? Does this seem fair?
I'm logging still.
Weren't you here? I saw you here.
I was, but I had to log out because it was buggy.
Oh, okay. What do you think, Nathan?
I don't know.
No, you don't know. That's
I
interesting.
love this type of comment. I don't know.
Okay, let me say in another way. I'm not sure.
Okay, so let's
It's
think about the evaluator, because usually I understand better the requirements of a new node in the expression level and when I'm evaluating it. So
Uh,
if you have a, what do you need to evaluate a nominal record?
that's not a good example, then.
What
uh,
do you mean by good example?
of Okay, example is a specific case in which you will like see how the thing behaves, and we can see why to take that decision, the other decision, or any guess on how to implement it. And I'm saying evaluation is not a good like example because it's very simple and has nothing to do with the types.
No, but
Because
we're not talking about types at the moment.
no, but the thing is, what is the difference between like the two records? It's only the type system. The evaluation is the same thing.
No, but
Like
if
they
that's the
behave as the same
no,
data.
but that's the thing. If that's the case, why do we need a label here then?
No, no. Again, what you want to know right now is what should we do in the ST, right?
In the
And then
expression AST. Yeah.
yeah, and then you propose, oh, let's do a look at the evaluator because usually that gives me a gist on what I need to be the expression and and so on, right?
Yeah, usually for
But
me that works.
yeah, that might not be a good one in this particular case because what we are doing, like the nominal record stuff, the only thing it changes is, as we said, the comparison of types. So that only affects the type system, right? So evaluation wise, you have the same data. They behave exactly the same. Uh, is that so like what can I say? Like we have the record value, right?
Mm-hmm.
It will evaluate to the same one.
Yeah, but then I don't know, that conclusion leads me to believe that we don't need two different nodes.
Again, the
I'm not
way
sure. I'm
that
not
we
sure.
are, like the things that we need to, uh, how can I say, pay attention on what do we need is to see how that would interact with the type system, right?
Yeah, so that's up here. So let's go up here. Okay, so before when we added the anonymous record one, we added a type, and that type is composed out of, I guess, the name of that field and the type of it. And my understanding, again, my understanding, no, my intuition is that this is just the same. But in here, it makes a lot of sense that the label is here. Makes a lot more sense than down there.
Mhm.
yeah.
Because we need this in order to compare like the names of it, right?
Uh, yeah. So, like as we saw in the Wikipedia page, the way you do the nominal stuff is having the type being declared before, right? So you can give it a name and refer to it
Mm-hmm. Mm-hmm.
and stuff.
Yeah.
So that's a thing. Uh, but then when you write an expression for that, how do you get that this is from that type, right? So I think that's one interesting thing to think about, and that will give us some hints. Like, for example, in the case of the anonymous record type, how are we like type checking, right? It's simple. Uh, the syntax will be like some labels and some expressions, and then the type is those labels and the type of those expressions, right?
Yeah.
Just like get them together, like in place.
Yeah.
But for the nominal one, that doesn't work. Like only the expression that the user is like giving us, like is mounting there the literal record. That's not enough information, right?
You mean to
Uh,
create a record, right? A nominal one.
no, no. To know its type, the user will create, and we have to give it a type. only what the user gave us is not enough to know its type, if it is nominal.
Only with what the user gave us. Wait, I think I need an example to see if I got that, because
Yeah.
I still think that we have everything that we need. So when I'm defining that, so I'm gonna do something like this. So we're gonna do like that. I have absolutely no idea how we're gonna make the syntax for that. But let's suppose that is the name in the first position, so I'm gonna call this name. So let's use your example actually.
It
So
would be the
person,
same as the algebraic.
the same as the algebraic. So it's like this, yes. Name, and then we give it a type. So let's say, I don't know, a string. And then here we're gonna put age, and let's say that this is an integer, right? So I'm defining that. What's the type of this? It is this, right? It is this. And then the type, the person will go here, the name will go here, and the string will go here. So isn't that enough to create this type? Well, not this type, the correct type.
Yeah, I was talking about what the user gave us in terms of expression, right? Not declaration of the type.
In terms of, you mean the use case of it when you're using it?
Uh, the user wants to write some data, right?
Yeah.
So he has a way to have numbers. He just typed the numbers. He has a way to wait.
So you're talking about instantiating a person.
Yeah, like writing like the data
Mm-hmm.
for a person, right?
Yeah, so I was thinking about using, well, I don't know the syntax, but something like person, and then we're gonna do the same syntax that we use for anonymous ones. And then you just put name equal, um,
Yeah, but the syntax like doesn't matter here.
yeah, and then this, and then we are also doing age equals to this. So I was thinking about doing like this.
Yeah, so like we don't have problems with any type so far, right?
I
Uh,
don't think so.
what I mean by problem is all that the user types regarding the expression, we can know its type just from looking at it,
Yeah.
right? Tuples, anonymous record and stuff. If you only give me this, I have a way to know, right, what is its type. But that doesn't work with the nominal record. Like, why is that? You declare the person there, and then you wrote that thing, and then why can't I know just by looking at the person itself?
I'm very confused on what you're saying. For me, if you declare that this record and I provide you this, you have everything you need to know that this is a person. This is already in the environment and stuff.
Yeah, that's the part that I want to talk about. With only it gave you there, the expression that I'm talking about, I was not talking about declaration in any moment. You don't have a way to know its type, right? Because you only have the expression that they gave you there. So you need to use the context in some way. Well, at least that's one of the solutions, right? Uh, so the thing is, you need more information. Like the simplest way would be to annotate its type always. Like every time you do.
Man, I'm still very confused on what you mean by like looking at it and knowing like you have access to the context. You already can check if person is a type.
Pretend you don't have the context.
Pretend you don't have the context. Yeah, but if you don't have the context,
I-
I'm very confused in your point,
Let me
Nathan. Could
try
you
to be
rephrase
more
it?
clear. So I'm going to do a comparison between the nominal record that we want to do and all the preview types that we already have. Okay.
Okay.
Uh, for all the other ones, the previous ones, you need the context to know the type of the expressions and etc. Right?
Mm-hmm.
But you don't use any kind of declaration, right? Just by looking at it, the expression, you can know its type.
Which expression you're talking about? Talk about this?
Any expression.
No, but that's not true, right? If you're looking at something that it is whatever, you assume that it's a type alias, and you discover later if it is. You need the context to discover if something is a type alias or not.
Yeah, that's fair. That's fair. The type alias is an exception to that.
Yeah, it is
But
the
it's
same here.
still uh, the same on T variable?
No, not the variable. It is the same as in this. You don't know what it is, but you assume it is something, and then later on, when you have the context, you just discover, as we do
Yeah.
with type alias.
Yeah, it's just different because the type alias, I have a name and I just look at it and I know what I got, right?
Yeah, in that sense, yes. Look at it. If it's not anything else, you assume it's a type alias. That's true.
To be more shorter, like we can either do something like you have the record there and you say what type it is, then I check in the context, or you can iterate to the context, see which type has this pattern, these labels, and then you infer its type, right?
Mm-hmm.
Like that's where I was like going, but without success.
Yeah, I agree with what you said there. Yeah, you can do that. What are the other options?
I'm not sure.
You're not sure.
I
Yeah,
believe you.
That's cool.
because for example, with the someone, we had the option of declaring the types, generate some functions as constructors to it, right?
Mm-hmm.
But that's because the function fits very well with with a constructor of a sum type, right?
Mm-hmm.
Or with a tuple, whatever.
Yeah, okay, that's true.
But that doesn't quite work with the record because, well, they can be out of order, but functions cannot have arguments out of order.
Mm-hmm.
So
Mm-hmm.
I don't think we can generate like functions to do that because it would lose a bit of the point of creating using labels out of order.
Okay, so the option that we have is that we need to consult the context.
Yes, in either annotating explicitly or not.
Okay, so if we annotate explicitly, we are done, right?
Wow, what
Like,
do you mean by that?
yeah, if you annotate this explicitly, you just say that this is whatever the syntax I'm going to invent right now. I don't know, string and integer or whatever. If you annotate that, then we know for a fact.
You would annotate with person, right?
Yeah, sure. So if you annotate like this, then we know for a fact where to look at, right?
Yeah, we just check, and if it's
But,
okay, we return
yeah,
person.
but doing this all the time sucks, right?
I guess so.
So something that we can do is to not do that, but I guess we would have to assume that this is a record, right? And then we need
What
to
do you mean
search.
assume that's a record?
Yeah, because in the partial level we can identify this, like a name and a space and this.
Why do you need that name there?
Well, because I'm creating the thing, right?
Why do you need the name person there? That's already a notation. By that, we would know it's.
Wait, so do you prefer doing at the end like this?
No, no, no. What I'm saying is, if you have the name person in any kind of syntax that you have there, it's an annotation.
I
And what
agree.
I mean by that is, we know where to look.
I agree. So what about doing that then? But wait, so the other option would be that this is a person, but we don't know.
Yeah.
Oh, I see. I see.
By the way, you have to, like this way, you have to change the syntax from the anonymous record one, right?
Yeah.
So we know that we should look somewhere.
Yeah, that's true. So we have a decision to be made here. So or we always annotate with like person or the other syntax, Or we do nothing like that and change the syntax of the anonymous record and the nominal record. Opinions.
I think something interesting to
Oh,
think about might be namespaces, right? Because when you are inferring stuff, uh, it's that thing, right? Suppose I declare person and I declare dog, but I declare dog last, right? And then I cannot really infer it to be a person because if you always infer to be a dog because it was the last declared, right?
Oh.
Unless in
right.
some type systems, if you do the annotation, in our case, we don't have that. It's like a general annotation, we don't have that, right?
Yeah, so the
So,
problem is that if you have the Haskell problem, that's basically it. You have two data types that have the same name. The solution to that is to use some sort of namespace stuff, like you said, or and you obligate the person to be very explicit, like person and then person, right?
no, no,
Or
no, 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 please.
no,
Why
wait,
would you put in every label?
why you put what? Oh, every label you mean? No, but just because I didn't want to annotate it, like in the beginning, like in here.
I see you're okay. You're going to
What the
put
fuck?
whatever.
Go on, Magetta. You were
Why
you were
don't
about to
we
say something.
make? I think I have a better syntax. What about this? Perfect. Or without this, maybe. And then we do this.
That's different enough to
Mm,
parse it as a nominal instead of anonymous. That's for sure.
yeah.
What do you think, Nathan?
So even the name is
The
is
syntax is
fixed.
not important to me, man.
Everything is different.
Okay, so it's not important. And later he complains that the language is
Yeah,
ugly.
the syntax sucks.
Because it is, but it's not important.
Okay, so I think then we're gonna go with the approach of annotating always. Is that correct, Magetta?
Yeah,
Okay.
yeah.
Okay. Okay, that's totally fair. So in that case, I think this makes sense. Do you agree, people?
Yeah,
What we
I think so.
discussed about has nothing to do with that.
No, yeah, no, but we already
No,
made a
it
decision
does.
because
We
I
already did
liked
the
it
check.
and
Mhm.
Magetta liked it,
No,
and
no, no. What you guys just said has nothing to do with the data type. Has to do with the data type expression.
What? Wait.
yeah, that's true because you're gonna be doing a let, right? Let's do some stuff. So you're gonna be doing
I
like a
get what you
let,
mean.
and then you're gonna do a name, and then you're gonna open brackets, and you're gonna do something along these lines, I guess, yeah. And then you're gonna do this. This is an expression level thing. So
Yeah.
yeah, nothing's correct. We are discussing the expression node at the moment. We are
Mhm.
doing that. So that's true. So I do like this is like I said, it's different enough to use it and maintain the anonymous record one. So that's good. So what about the type? What about the type?
I
Let's
think
discuss about the
that's.
type.
I think that's it.
I also think that's it, but usually
What is our context?
we have three contexts. We have a map that names a name to a type. We have another map that gives a name and an alias.
Well, okay, can you just show the type because that way it's
And then this is a kind. No, this is it. This is our context.
yeah. So the middle one you're saying is a name to a type also, right? With alias you mean a type.
Yeah.
Uh, so yeah, like suppose we don't create this node of the type
Mhm.
and we use only one type, right? Uh, then that indeed could be a problem. Why is that? Because if I'm for alias and for declarations, I'm putting both in the same map, the second one that you did there, then how do I know if the connection in the map was a declaration was just an alias to like anonymous record, right? If I
Wait, you're
have the
gonna
same node.
wait. Wait, so you're proposing, let's see if I got it. You're
No, I'm not
proposing,
proposing.
no,
I'm
you
bringing a
are,
problem.
yeah, you are imagining, I don't know how you want to call it. You're saying, suppose that we have,
Envision.
yeah, envisioning. You don't have the nominal record type, so that's gone.
You
So
only have one record type, right?
you only have one record type. So then how
And
are you
it
gonna
doesn't have a
differentiate?
name
Yeah, it doesn't have a name. How are you gonna differentiate an alias from a type,
from a declared type, right?
from a declared type? Well, that you can, because the alias will be in this context, right? Like it's gonna live in here, and the other one's gonna live in here, I guess.
No, 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 no. That's the type of variable.
That's the type of variable. So I think I need to take a look on how we do the
Yeah,
declaration of where it is. Type check declaration here. So let's think about that. So if you have a type, declaration of a type, which is in here, we do define placeholder stuff, kind checking stuff, and then we add to both. Yeah, so you wouldn't know. Yeah, you wouldn't know. That's the answer for your question.
so yeah, I'm going to like the most basic and dumb thing, so we can like see the problem and see like
Mm-hmm.
what does the name solve or if we really need it, right?
Mm-hmm.
So this first case we know like doesn't happen, like it won't happen.
Yeah,
It's
but
not
something that we
possible.
can do, something that we
Mhm.
can do, is to make one.
Yes. Why do you have a maybe text there?
Because maybe it is only an anonymous one, and then you can get rid of that.
Yeah.
Like
Sure.
you can do this, or you can do only one. Like this, and removing these two.
Oh, yeah, that's fair. It sure I would say it's worse to have the maybe just because it doesn't have as much semantics as like having the proper names, right?
Yeah,
But
yeah, that's true.
yeah, another step that I would say it's like natural for you to try after the one we tried is okay, what about if I have the two different nodes, but none of them have the name, right? None of them have the text in it.
Oh, you mean removing
How would
like
that
this?
work? What would be the problem then? Yeah.
Because two different nominal records that have the same types and same name fields, they would be equal, I guess. They would be the same type, but they can't.
Yeah, that's very interesting, but that depends, right, on how you do stuff.
That depends on how you do stuff.
Yeah, in the sense of how it's your equality and such. But okay, let's try to go on that. Uh, Now I can know if the thing was like declared as nominal or if it is
Uh,
like just an anonymous that was
mm-hmm.
allies to something.
Yeah.
So the inference that we want is you have the name for the type. So okay, I have how can I say a name, right? But the
Mm-hmm.
name would not be inside of the node, would be on the left side of the map, right?
Yeah.
And then I would just check if they match. If so, oh, wait.
I don't know how you're gonna do the comparison between two different nominal records without having the name.
How are we doing the comparison of the things that are alias?
We are just inheriting.
What do you mean?
Well, the comparison is just Haskell comparison, so it's a field by field manner and stuff.
Uh, okay, so
Could you
how can
give
I?
me an example how we could solve that? Like
Uh,
two different nominal records with the same fields and names and the same types.
no, yeah.
How we
I'm
would.
thinking about how we do it alias, right? In the sense of, how can I say it? Uh,
How we compare them? I don't think we
not
compare
a,
alias never, actually.
Yeah, I don't think so.
I think we always translate them to their proper, I don't know, so I would say.
So
I think that
yeah.
if you have an alias, like you are immediately converted to your real deal.
Where do we do that?
In the beginning here, typer, here, find placeholder alias.
That's a type check declaration. So what does that return?
That return is always a type, but like we don't have the only T alias that we have is when you have the T alias
Oh, we
placeholder.
don't, but yeah, we don't return the T. We return the T80s, right?
Yeah.
So we return the name that you used.
Yeah, when I said that we never compared T aliases, I meant T alias placeholder. I'm sorry.
Yeah, how are you doing the equality of the T80s?
It is Haskell. Haskell's comparison. So it's
Are
the
you
name.
sure? Like,
I am 100% sure. Here.
yeah, this part I
yeah.
remember.
So I guess we had functions messing with it, but were other functions then, right? So reduction or something
Yeah,
like that.
reduction and yeah,
Substitution.
yeah, exactly.
Yeah. So yeah, right now I think they have a bug then.
Cool. So what is the bug?
Because for example, if I do an alias to A saying that is int, and an alias to B saying that is int, they should match.
And they
They
will.
should be equal.
Yeah, they will, I
But
guess.
they will
I remember
not be.
having this. I remember having this discussion, man.
And what was the
Really?
conclusion?
I don't recall. Can we try?
Sure.
Let's
Because
see it.
in my view, if you have the tape alias with different text, well, then it'll be not equal.
Okay, so let's test that. So let's make another integer here. Let's
Here's
call
some
it
pictures.
weight. Wait, I don't know how to type anymore. This. Okay, and then let's do a print. Um, it's gonna be a print of a boolean. And we're gonna
You already
print
have it in place. Next time.
what?
You already have it in place.
In place. Okay.
Like the code that you need to test.
Oh yeah. Uh, so let me think.
Dude, just call print weight passing
Wait, we
like
can
something
use
that
the
has
REPL
like
for that. We don't need this.
So you can load
Uh,
this. Like I thought it was broken.
no, it's not anymore. I fixed it on Sunday. So let's do a def alias, mass integer. And let's do the same for weight. Right. And then we need to, well, we can compare mass with weight, like directly, right? We can do that. We need to make,
yeah. Do the first test is do a function that expect mass and just pass the integer, right?
no, but that works. That we already tested.
Oh yeah, but not because of what you showed. Go to the application, dude.
To the application, what do you mean?
Type check of an application.
Oh, type check of an application.
Yeah, we had two of those functions, right? One of those was to totally unwrap it, I guess.
Um, e application. That's what you want?
Yeah, so the functions that we use there. Ah.
Yeah, we reduce both. We reduce both before
But we don't
comparing.
use. Yeah, that's not what you want. Go to the abstraction
No, but
one then.
now I want to see what the reduction of reduce type does.
Yeah, that's.
Yeah, it will work, dude, because of this line here.
Hmm?
Yeah, we are ignoring the name and just proceeding it to the internal thing. So that comparison
Oh,
there will work.
okay, I see. It's unwrapping the thing.
Yeah, we are unwrapping the reduction.
Don't we have a third function, dude?
Well, we have find alias placeholder, reduction, type substitution, and kind checking.
We don't have a second function for alias stuff.
I don't think so. Find placeholder is the only one that I remember.
So, okay, we did on reducing type that we get rid of stuff.
Yeah,
Okay.
yeah.
So, yeah, then that's right. And then I think that
Oh,
already
wait.
like,
Yeah, no, but we can test that now. We are just being dumb here. Just call this y and wait. And then we can just call the boolean here, bool, and replace this with equal xy. And we pass 60 and 60. And that's it. And that should work just fine. So let's quit of this. And let's do the same f alias true. Yeah, alias you can compare.
yeah. So I think that already gave us the thing that, okay, not having a name will not work, right? Because if we rely only on the name that was given by the
Yeah,
alias,
exactly. Yeah.
like we are getting rid of that, we would have to change that.
Mm-hmm.
So indeed, we need an extra name. And yeah, then I think there is only one problem left.
Okay, go.
So the first thing is that we have a name there, right, on the nominal one.
Mm-hmm.
And the other problem is still depending on what is your, let's call it, declaration policy.
Mm-hmm.
That can still not be enough to say if they are the same type.
Can you
What
give
I
us
mean
an
by
example?
that, yes, go to your code.
Go to my code here.
Yeah. So let's suppose you do, well, let's suppose you are declaring some record there, like the dog, right?
Okay.
And then you create a variable, somehow that variable gets this type dog, and then you declare the type dog again with the same record, right?
Mm-hmm.
And then you create another variable with this new dog type, but they are like equal in the body, in the name.
Mm-hmm.
They shouldn't really match as the same type. Just because they have the same name and the same thing, they are not the same declaration.
Yeah, but then we're
So
gonna go to the whole temporal BS stuff.
but yeah, then you have two options, I guess, to make like foolproof.
Yeah.
Either you don't allow you to
Or you use a hash.
redeclare. Hash is the worst way. Yeah.
Okay.
So the options that you have is either you disallow the person to redeclare it,
Yeah.
right? I don't know exactly how that would work if we would just, oh, if it is on the map, fail already.
Yeah, pretty much.
Yeah, I don't think that's as simple because at least when you have like different
Oh, we need to know when that
modules and
happens.
stuff,
Yeah. Also.
no, that happens on declaration.
No, but that like let's suppose that you are doing some consultation, like you're doing consulting the environment. In the beginning, the environment will not have that, right? And then you're gonna insert it. But then later, when you want to consult it again, it will be there. That's not an error that per se, you know?
No, dude. Declaration. If your declaration, then name and the name is there, then you can call it an error already if you want.
Oh, okay, as a declaration.
When
I was
I'm
thinking
declaring
expression.
the second dog, you can already error if that's your approach, right?
Yeah, okay, but go on with your idea there.
Yeah. It is as simple as you said. Oh, just don't allow it. But that's only when you always have the same, like, top level scope stuff, right?
No, but that's only module stuff, no?
No, yeah, the problem that I'm thinking is when you have modules, right? If they come from different places, right?
Yeah, then I think
Uh,
we should put a warning saying that you should specify which module, but we're gonna use the current one.
like, I think that's too complicated. I think we might just ignore for now
Oh yeah, for
the,
sure. No,
the
I'm just
module
saying that
application.
if we had modules already working and etc., that's how I would do it. But because we don't,
Yeah,
I was not even considered that an option.
I will not even think about the implications of like, modules and stuff. But yeah, then we can go with that. Just fail it.
Okay.
Because just to completion, I was talking about another approach. I don't know if I remember. Yeah.
You
Oh
may.
yeah, okay, I remember. It
Okay.
was not a hash, but it's a counter. And why is the counter better than a hash? That's because it is something that you can show to the user. You can say the following: Oh, record name dog. You suppose you even want to show the body. It's not equal to this name dog with the same body. The user will be confused. So you could say, oh, but this was declared first, this was declared second,
No, yeah,
right? The counter will go
that's not
after.
a very good argument because you can
The
save the.
hash doesn't tell you shit.
No, but that's wrong because that's a dumb way of doing a hash. You do a hash and you save the original name for your messages, of course.
If but if you have the counter, you don't need the hash.
No,
It
yeah,
would be
I'm not saying I prefer the hash. I'm just saying that if you're using a hash, there's no fucking reason to not save the original name.
but that's the thing. What do you mean by name? You mean the name dog?
Yeah.
You have to save that anyway, right? What you need is a way to differentiate the first declared and the second declared.
Yeah.
You will have the name of both. If you approach with the hash, you just say, oh, this hash blah 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 is different from the blah blah blue.
No, you're
You
gonna say
see?
that. Oh, you're gonna say that this. Well, I'm not gonna say that you're gonna print the hash on screen to the user, but you're gonna say that
Yeah.
dog. Which dog you're talking about? That's you. That's your
Well,
message.
both? Well, what would be their message? What are you talking about?
Which dog are you talking about?
Yeah, that's not that useful as having like the numbers to tell you, oh, this declared first, this declared second, right?
Yeah, okay, I
But,
agree that having a counter would solve that.
but yeah, so you already know what to do, right? We have a text there, and if you try to redeclare, that's a error on you.
Yeah, but which approach you should use? This or the two separate ones?
Well, for me, it doesn't matter much because the same thing. But I do think they made like semantics.
The maybe.
Yes.
I'm gonna go with the other one just because I'm lazy right now and I don't want to implement the anonymous one.
That's a good argument.
Okay, so now we have the data types for both the expression level and the type level, and they are exactly what I envisioned. Oh man, okay. Um, yeah, I'm gonna do the same here. We can unify both, but I'm gonna do that offline if I will ever do that. Okay, we also need to
Unify
add in
what?
the records to have only one with the maybe stuff instead of using them separately. So let's add a new. I think we also need to add a new declaration. Is that correct?
Well,
Or we're
that
gonna
depends.
define the record as just a type, like a def algebraic also. Hello?
Wait. What do we have right now?
We have expressions, functions, values, types, and the
Wait.
module is here, but
What?
ignore that.
What is the difference between expression and value? What the fuck?
Well, this is your defining a constant to be used later, and this is just a loose expression.
Oh. Yeah, because we are recording those declarations, right? Oh, I see. I see, I see, I see.
Yeah, so from my perspective, the record would be this. Is that right?
Well, that depends. That
Right, we're gonna
depends.
give a name to the record, like person, and the type would be the T nominal record up there.
Yeah, that's the same question that I'm pretty sure we already talked about. We talked about, do we need two different declarations for, well, type declarations per se of
I,
nominal types, and two type alias, like do they need different declarations? And I think the answer was something like only if you want to treat them differently, of course, right? Otherwise, it's the same code.
yeah.
And one of those cases, I guess, was regarding inference of kind. Um,
Inference of kind. So you're talking about this piece of code down here. So type check declaration again. Declare type. Then we need to see if this piece of code can be used for both, or we need to treat them differently. Yeah, I remember that discussion. Yes. So let's suppose that this is a record, right? So this is person, and in here we have the T nominal stuff with the same person inside as well, by the way, with the same name. So then the question is this what we should be doing with
well,
having a record, a nominal record?
uh, I don't think that's quite the answer that you want. If your question is, does that work? It does.
No, no, but that's not my question.
Okay.
My question is, does that make sense?
Well, if it works,
No, no, no. If it compiles, it works. That's the philosophy now.
no, 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 no. What I mean is, it works. Like, has the expected result. I'm not completely sure what you mean by makes sense.
Yeah, so is this doing what we should be doing? That's the question.
Yeah, it would do.
Okay, so are we lacking anything by considering records just a declaration of a type?
Yes,
Nominal records.
that's a good fucking question. So trade-offs, right? If you do that way, it works fine. You can receive your kinds. Well, you can receive your types and annotate with kinds,
Mm-hmm.
and that's fine. The way it would benefit you from have a different declaration for those is because then I guess you could do kind inference. You would not need to annotate the parameters uh, with its kind if you want to.
Wait, I'm confused. In which situation exactly you're gonna have to declare the kind explicitly?
Okay, not declare, annotate, right?
Annotate, sorry.
So when we are doing either alias or like declaring nominal types, we can receive types as parameters, right?
Oh, I remembered. I was completely forgetting about that. Completely, completely. Yeah, so you're saying that if we want to... Oh, that would be kind inference, yes. Holy. Okay, go on, Nathan.
So yeah, so and the way we have right now is you can like say what are the parameter names, and then you have to annotate with a specific kind, right?
Mm-hmm.
Oh. There are some things very interesting right now.
Wait, are we doing that with alias?
What?
Because alias also you have to say... Oh, we're not doing the kind inference.
Well, we are not doing with anything. I'm saying something that could be done.
Oh, no, but I thought you were saying, oh, we are already kind of doing that. Kind of doing
No.
that. We are kind of doing that already with alias, and we will not be able to do that with records. Yeah, so I think that because I'm gonna, you can go on, but I think we're not gonna implement this right now. But you can go on.
Yeah, I also think it's not wise to spend the time on that. I'm just saying, like, what are the trade-offs, right?
Yeah, go. That's
Uh,
interesting.
so yeah, if you were treat them differently, what would be the thing that would allow that? It's because every type inside the record or a sum type, right? They are types that have the kind star
Oh, you
always,
know that for a fact. That's true.
right?
Yeah.
They can only be that because they need to like carry a value at runtime. So its types are kind star.
Yeah.
That's the
Yeah.
point
Yeah. You,
there.
you would be able to infer that. Yeah.
So with that, I would be able to easily infer.
Mhm.
With alias, not so much. Because if I do something like I receive the type F and the type X, and the result is just apply those, there are infinite kinds that could like fulfill that thing, right?
Mhm. Yeah.
One thing we could do is assume, right? We could assume. We
Yeah.
could assume that the result of the whole thing is kind star, right?
Yeah.
So that would be the default inference. But if he wants something different, he can annotate, right?
Yeah.
But yeah, maybe that's quite a bit of trouble to implement. But yeah, just talking about like what might be possible, right?
Yeah, but that's a totally cool. I was not even remembering that, man. That's so cool that you remind us of that. Okay, but if that's the case, you don't need to add a new declaration. We can just go then. So let's just start with the typer today. And just by the way, just to everybody to be in the same page, I latest updates that I did on Sunday, right? I nuked the module stuff that we did that didn't work. If we want that back, we can
Actually, it
just
worked, man.
no, it didn't work as we wanted.
Well,
So
like how did it wasn't like not working.
anyway,
Yeah,
we can retrieve the code in on GitHub. That's fine. I just made like this because I needed to separate the behavior of a single declaration from the behavior of everybody else because of the REPL. So before we were doing type check declarations and that's it. That was only it. So the thing that I did on Sunday is that I separate these. So now they work differently, separately, and one called the other. So in the code, the type signature of type check declarations and the behavior is the same. But how it does that, it calls the type check declaration individually in the fold now. And that in that way I can reuse this function for both the REPL and the interpreter.
was that being done before?
No, that was not being done before.
So how was that being done before?
Oh, I was doing the
The implementation of type check declarations.
oh, it was basically like this, but instead of returning an either, it was always returning a type env, and this function was being called in the fold as well. And that's it. So the only thing that I did is that I added an either because I need this when I'm using the REPL, but this is useless otherwise. So that's why I'm calling the from right here. For the type check declarations, we never want the result of a single expression. So I'm just nuking this and I'm retrieving everybody else exactly as we were doing before.
Wait, either type or typer env? What the fuck? Now that I know that.
Yeah, that's what I said before. Type check not before. Type check declarations is still the result in a type env, right? In a typer env. But the problem is that having a typer env is not necessarily useful for the REPL. I need to be able to have both things in the REPL. So the way that I did that is that I extracted
Oh, I
the
see.
common behavior from type check declarations and make type check declaration. But in the type check declarations, I ignore the lefts. So if we receive a left from this, inside the result, of course, you're gonna just ignore it and put accumulator because the accumulator is the env. So in that way, this will behave the same as before. You only environment stuff, but I can reuse this because there is the corner case in which I need the left in other situations. And I did that for both the type
What is
check.
that case?
Um, it is the case when I want to print stuff in the REPL. Like I want to print the type, I want to print the value. Because when you have type check declarations, both in the type checking and the evaluator, we were ignoring, right? We are completely discarding the
wait,
result of this.
wait. Let me go a bit slower. Maybe I'm confused here.
Okay.
The situation is you have a declaration, well, you have an expression and you want to print the type of it.
Mm-hmm.
Then you shouldn't be calling type check declaration. That's type check.
You're right. You're right. But it was very, very annoying to try to, because before the previous approach, I can explain here because the code got a lot smaller when I did that. So the thing that I did is that I didn't want to mess around with different sorts of declarations. I didn't want in the level of the REPL to care which declaration you are passing to the REPL. Because you can pass the REPL whatever, right? You can pass even full-fledged declarations of types and alias and stuff. And I didn't want to care. Before, the reason why the REPL was not following the interpreter was because the REPL I was doing it by hand. I was separating which type of declaration you were giving me. Because if you're giving me a declaration of an expression, I need to print that on the screen. That's not a behavior that the interpreter works. If a declaration of an expression goes to the interpreter will only do nothing, right?
Hey. But oh, I have a thing that might destroy your heart, Leons.
No, just go for it. I have no problem.
Not about his heart, but the REPL maybe.
Yeah, but uh,
Go.
don't the REPLs usually also print the type even if you are typing a declaration?
Um, I don't know because in Haskell we don't have that, so I have no clue.
Well, no. What they're saying when you say x equals something, that's a declaration on your Haskell REPL.
Yeah,
So does that return the type or not?
no,
No.
no.
Really? That's very interesting.
Yeah, I don't remember Haskell returning. I know
That's very,
Spatula
very interesting.
used- No,
But we can. That's the
used to
thing.
do.
That's why I made this. We can do now print the type if you want. That's easy. I'm just ignoring that in the REPL. Look, you see where it is my tuple.
But if
Here,
it
you see
returns
this?
you,
You see this?
what is that?
This is the type
Oh,
of that thing.
the tuple.
I'm
So
not
if you have a tuple, like if you were asking for an execution of whatever, of a declaration in the REPL, right? I'm gonna parse that using the declaration parser. I'm gonna call a function that does both type checking and evaluation of that. And then if you want to have the type when I put that x equals 1, just if you want generic REPL success. That's why I made that.
Wait.
And then you can just put T here and then you're done.
Can you show me the type check eval? Because on the declaration, you are saying that it returns either a type or an env. So if it's a declaration, you are turning an env. How do you know the type then?
How do you know the type? Oh, here. Because in the typer level, in the type declaration level, I do know, right? So I am pattern match the declaration. If it is an expression, I'm gonna return. I know that the person, like
Oh, yeah,
supposedly
sorry.
know that.
I mean from the consumer point of view. So when you have a declaration, and by declaration I mean a declaration, you have x equals something,
Okay.
you will return a right. That's an if, right?
Yes. Yes.
So how do you know its type? The type of x?
Oh no, but that I don't know.
So how can you print it? So I think you can't do the
Oh no,
x
wait. I
equals
expressed it
1.
wrong. I expressed it wrong. If you put 1 in the REPL, I would be able to say 1 and the type.
Oh, yeah. Okay, now I got it.
There's something interesting here we could do. Can you take a look?
Yeah, sure.
Yeah, right? Right, like it says it.
Okay, so what is that? So let x equal. Yeah, that's a problem. Well, that's not a problem
Yeah,
because it's very easy actually now that I already separated the two. Because the only difference is that you would be changing this to a tuple instead of an either, and this would be always second instead of whatever from right accumulator is. So yeah, we can totally do this sort of stuff because now the interpreter follows this, by the way.
Yeah,
And
but look at the second. I think it's the more interesting one.
okay, the
Like
second is
you
once
make
plus two.
type a loose expression and then it assigns to this it. So then if you call
That's
then in,
interesting.
you see?
Wait,
So,
Magenta, that's a shop?
yeah.
Can you refer to the it indeed?
Yes, sir.
I think it's only for printing, camel
That's
in
kind of
some
cursed,
languages.
though. That's kind of cursed, but okay.
Why would it be only for
Wow, some languages are. And by the way, I think that's a great idea.
Wait, what? To have the it?
Yeah, I think in Elixir it's underscore and you can also refer to it, but
Dude,
I could be mistaken.
I like the combo list in SPCL. I remember being able to do like asterisk and then it picks the last one, or asterisk asterisk and then it picks like, and then
Oh,
Oh,
that's kind of smart. That's kind of smart.
like, oh my god.
The previous one, right? That's kind of cool.
Yeah, that's kind of cool. We can totally do that.
By
But
the way,
anyway,
Lemos, wait, there is still one question.
okay, go.
When you are type checking a type declaration, what is the type that you return?
That's a good question.
And what does it happen in F# REPL? Show us, Magenta.
Say it again.
Declare a type in
Mhm.
F# REPL and show us the
Oh, okay. So,
result.
so ABC, I'll make
That's a very
A
good question indeed.
B.
But anyway, something that I
You
spent a
just
lot of
chose the
time
type.
thinking how I would do this. Like, how the heck I'm gonna make the REPL follow the other stuff if the behaviors of them are different? Then I
Oh, take a look, Clemens. Indeed, we can just like put the type itself, the right side of it, right?
yeah,
Maybe
we
we
can.
wouldn't have all the information printed. I don't know. Probably not. We wouldn't know it's a type declaration. Only it's a type. Well, I don't know, but we know
Oh,
that we can type check it.
that problem that we have last time, that the REPL was not having the left constructor available in the environment. When I added this thing of like using the type check declaration inside, that went away right away.
Wait, what?
Last time around, last session, after the recording, we were trying to test some things on the REPL, and we didn't have the left constructor available in the evaluator environment
Okay.
because we wanted to ask the type of the quote-unquote tuple, right, that we did, and that was not available for us to use. And then I said, oh, this is because the REPL is broken. And it was broken because the REPL and the interpreter work in separate paths. But now they work on the same one, because if we change eval declaration and type check declaration, both of them will manifest problems, and then we fix one single place and both of them will be fine.
Golden question. Is the REPL like inheriting like everything as it can like right now?
Yeah.
Nice. Because it was really strange not to, right?
No, but that's the thing. The problem is that the interpreter and the REPL, they treat expressions differently, the declarations of expressions. The interpreter doesn't give a fuck. But the REPL prints it.
If the REPL is just using the API of your language, right, then it should be able to inherit everything. Because, well, either your API is not providing enough, or you are recreating inside the REPL, and then you would know like implementation details. Like,
Yeah, but that's
makes no
exactly
sense,
the
right?
point. Now this API, quote unquote API, because it gives me more information, because before it was only the env. But the REPL cares more than that. He cares about the env, and sometimes he also cares about the return of that. So then when I added the either, the API got better. But to do what Mageta is suggesting, to make the it stuff, that's easy. We just change the API instead of either to a tuple, and then both the REPL and the interpreter say we need fixes, and then I fix them, and then they are fine.
Yeah, indeed. I think you wouldn't be able to do without like the API improved, right?
Yeah, the API improved in the separation of concerns. Like this is the bridge between the REPL and the interpreter now. This function. Because both of them call it and both of them will work around it. But anyway, I just wanted you guys to know that this is the difference between the code on Friday and now today's code is that I did all of these on
By the
Sunday.
way, I still think it's weird the way we are doing, even though it works, because how can I say? Like for example, Camel, you don't have the declare expression as we do, right? You
No,
don't
yeah,
have a declaration that is just an expression.
yeah.
So they have the ones to type check declarations and return the if, and they have the type check. The way they do is they apparently match that in the REPL, and then they decide what to do, right? I don't see a bad thing about it, but yeah, that works.
Okay. So now let's do type checking. So where are we gonna do that? Let's do in the beginning.
Why don't we start giving an error when trying to redeclare something? It's the easiest, I guess.
Trying to redeclare. Oh, you mean in here?
Yeah.
Okay, so we're gonna apply that philosophy to everything?
Hmm?
Yeah, because we have multiple declarations here, right? We have
I
declaration
don't
of
think you have a
values.
way to this thing. Wait.
We do have a way to distinct. What do you
Oh
mean?
yeah, if you look the contents and see what it is, right? Yeah, you're right. I don't know.
Okay, so let's try. So this will be check existence, I guess. We're gonna pass it a name. So this is a text. And
Dude, that's wait. You really need that because that's already a set function, well, a map function. Exactly a map function. It will be check existence is equal to a map function.
is equal to a map function. Well, I'm gonna
Like
make it
map
here and
dot
then
head.
later we can see if we can just remove it. And this will also require the typer env. So this is the name. This is the typer env. And then we're gonna do the following. So uh, if the name is already in one of the three maps, because we have three
Oh,
map stuff.
we check. You mean giving the error already, right?
Yeah.
If you. Oh, I see.
Okay. So if map. Oh wait, I don't know if
That's
this.
very imperative of you, man.
This is not an if. This is a pattern match, I guess. So data map Haskell. It is indeed very imperative. I have to agree. So it's member. It is a boolean. Okay. So if map member name. If we have that in the variables types, and then we can just copy, well, do this. Then, oh fuck, how are we gonna know which one? That's a very good question. Alias
Wait, what?
context.
Wait. What is that, dude?
And then here it's gonna be kind context.
No. Wait. What is that, man?
What do you mean? What is that?
Uh, how can I say? We are dealing with, you are declaring types. You are only dealing with the alias context. The other is for variables, the other is for kinds, like they have nothing to do with it.
You only care about it in the context, in the alias context?
Of course.
What if you have two different? Oh, you're gonna do
Actually,
shadowing,
the
right?
kind, huh?
We're gonna do shadowing, I guess. If you have like a lambda inside a lambda and then they use the same parameter name.
No, yeah, that's completely something else, right? Values, they would still have shadowing.
Yeah.
But I guess alias context and the kind, they are kind of mirrors, right?
Yeah.
Some sense. But yeah, checking that's enough.
Okay, so I don't know, label already found in alias context. It is mapped to and here already. Then we're gonna do show name. Actually, it's not show, it's unpack. And this is gonna be, yeah, I don't want to retrieve this value, so this is enough. Okay, and then else we just do pure. Which ones we need to check that? I'm guessing all declarations that are not expressions. Existence name. That. And that as well. Okay, done. Okay, let me close this, don't save. Okay, so now we can go to type check expression stuff. So let's suppose that we want to do this.
Did I totally vouch for that, Nathan?
Transform that into a drawing that you use for the logo for a future pro. What the heck is that?
It's a capybara.
What
Yeah,
do you
no,
mean?
that I know. I'm asking which project.
I don't know, man. We
A
find
future one.
we pick a capybara and then we find the project. Man, you know
What the
Victor's
crap?
blog? It has a capybara.
Yes, I
on the
know.
logo,
I looked
right?
at it for a long time because I was
No,
copying to make
I
mine.
don't know if Nathan knows.
Yeah, I know. Well, it's more than a blog. It's a whole. What is the name? Community, dude.
Man, the dude literally paid for a dude. It's a Brazilian dude to draw this.
Yeah, I remember that. E-condition, type,
Like, you see the Discord that it has on the site? It's a whole community, dude.
Dude, you know what's funny? Like that picture you sent of a capybara jumping in the river. That actually looks like that could give a good logo. To be fair, like
Oh, that's what I said.
unjokingly, that's good.
Unjokingly.
Joking.
Okay, so let's do that. So I'm copying.
Undefined. That's our JavaScript of you.
Okay, I'm copying those. So what we're gonna do about this? I think it's exactly the same, actually. It's 100% exactly the same. But we're gonna finish saying that this is a nominal, and you're gonna just pass the name. Any problems with that?
Wait. Fields? See?
Yes, I just looked at that and I cringed.
By the way, that's a map. But despite that, then
It's a
you.
map, Lemos. I'm not
Yeah, if
100% sure about that, Nathan.
if you're always doing zips and unzips, that's a map.
Zips and
Uh,
unzips. There's
but
something else that you
unzip
can do. There's something else that you can do. It is cursed, but I'm gonna show you anyway because it's funny. We're gonna
worse than
p.
unzip and zip?
Yeah,
Oh.
we can do this. Check expression env, and then we put t anonymous fields. In the case that test is not this, if that's the case, we're gonna just transform it.
Wait, type check expression and wait, that doesn't make sense. You are passing a type to type check.
Oh, sorry for that. It's not T.
Okay.
And this is an error.
Wait. That is something weird there.
Mm-hmm.
How is your expression for? Wait, that is something really weird there. How would that be different than anonymous record?
What do you mean?
That's always anonymous record.
Well, I don't know what you mean by that, but
Oh,
okay.
I got it. Oh, I got it. I got it. Now I got it. Wait, that doesn't. Yeah, I don't think that worked, man. Uh, so go with your original idea because might it might have a problem.
No, can you tell me the problem?
Well, delete that and comment your code.
No, no, I'm saying what is the problem with this? Aside from being
Oh, the
cringe.
same with the other, I guess. So let's go with the other that we know it's less bad,
Oh,
I
okay,
guess.
so if it's bad, we need to go to the anonymous one. What is... Okay, let's go then. So what we
Noted.
want?
It's bad using this to type check the nominal one.
Oh, why? That's what I want to know.
Go there.
Okay, go there.
So, okay, the thing you need to do is you are receiving a name.
Mm-hmm.
Then you need to get into the context, see what it is, and then see if they are equal.
Wait, what? We need to check the context? Okay.
Yeah, you need
So
to.
map member name inside the alias context.
Well, by check, I mean you need to get its type, right? Not check if it
Yeah.
exists.
Oh, okay, sorry for that. So you were talking about doing a case map lookup of the name inside the alias context, right?
Yeah,
If it's nothing, that's a problem.
that's a huge one.
This is gonna be didn't find type record type.
But yeah, the thing about unzips and zips is, man, you're literally doing a map on the second member, right?
And this is gonna be unpack name. And then if we find it, what we should do with that?
It has a type, right? You
Mm-hmm.
compare if it's the same of the fields after you type check it.
The same as the fields after I type check it.
Yeah, so before you are type checking the fields, right?
Before I am type checking the fields, yes. I'm still having a question though. What is this type? Isn't this T nominal record?
Yeah.
Okay, so we do need to type check the fields still. So then you need to compare if, and I guess we need to reduce them because of
Wait.
the
No, no,
thing
no.
there.
Wait. Not that way. I was talking about the for, right?
Yeah, but we don't need to do
You
the for.
need to.
The anonymous way already does that for us.
Okay. Trashy, but okay.
Yeah, it's cursed, but it works.
Uh, there you have the fields. And then you need to check if they are equal to the fields inside the type prime, right?
Inside the type prime. Wait, so we do care about the result of this, right?
Yeah.
So if this needs to be just T nominal, T nominal record, save name and saved fields, which means that this needs to be this.
Yeah, we don't care about the saved name.
We don't care about
Well,
the same name.
yeah.
Okay.
We know it's equal to name.
Yeah. Okay. Just a sec. Record type is not a nominal record. It is whatever is that. Shoulder. Okay, we don't care about the name. Then, uh, then we do this. Then we need to compare them. My question: do we need to reduce them?
Good question.
Like reduce the types inside the tuples of the fields?
Yeah. You do. Yeah. I think
Yeah,
we had a lengthy discussion about like every time you are
every
matching
time.
or
Comparing, you need to
equal.
reduce it.
Yeah.
Yeah.
Every time comparison is there. Okay, so I don't know, list for now. Map second this with saved fields. Then we do if list equals equals. Oh, we need to reduce both, right?
Yeah.
We need to reduce.
You can do it the. Oh. Yeah, you need to do again with
Yeah.
the fields.
Okay, so reduced saved fields. And then these will be only this, I guess. And then if the reduced saved fields are equal to reduced fields.
Well, you need to sort, right?
It can. Oh yeah, this is not sorted. These ones are. No, these ones are, but no these ones. Crap.
Wait, which one are sorted?
These ones are already sorted.
Like, wait, you have to sort both, man. To
Yeah,
compare.
that's what I'm saying. The
Is
other
there a
ones are not.
way- No, there is. If can you iter on a map with two at the same time? Because
What do
then
you
we
mean
don't
by
need
that?
to sort, I guess.
I don't know what you mean.
It's just a.
You mean
just,
the map 2 that we have in F-sharp?
yeah, something like this.
That's the zip width, but we still need the sort.
Why do we still need the sort then?
Oh, but because I'm thinking it's from like it's based on key, right? So maybe it converts to iterable, and then that screws up the plan. But
Wait, you want the list to a map and then do map equality?
no, I wanted to literally map the map, but like map two, you know. And then I was thinking, does it get both in sync with the key name or not? I don't think so.
Oh yeah.
But then you would need to sort.
Else. Okay, so what is the error if they are not
Wait,
equal?
you cannot get away if you don't sort both.
It is sorted both, man. What are you talking?
What? Oh yes, it is sort by.
No, he's
Wait.
complaining
Oh,
that
wait.
field is not sorted, but it is because the type expression of anonymous record already sorted them.
On the return of... Wait. Can you show us that?
Yeah, of course.
I like how Nata doesn't trust anything.
Yeah, it doesn't.
Well,
Never.
I'm not seeing, so...
Never, he never.
Look, you returned the P anonymous record
There's a zip
and...
there.
but you're in sorted.
I mean, bye at this point.
It is 100% sorted, dude. Okay, so what is the error message of the error if they are not equal after being sorted and reduced?
By the way, it does give
It's not
false.
equal, it's not the same type, right? So,
Yeah.
Sorry? Sorry?
yeah, so it's just like type is matched, not the same. Like not the expected type.
Okay, so
Uh,
type
But
is
does
matched.
the equal on lists like handle properly with length and such?
Yeah,
Okay.
type is match between what? Between the record, between record declaration and instance
Our
this.
interpreter must be so slow, man.
Miss what?
Our interpreter must be so slow because things like normal things will make it slow. Like for example, you declare a record that has like I don't know, 100 things. Maybe not 100, but
No, it's gonna take a lot of fields in order to the list to start like being like. It is inefficient. I'm not saying it is because it is unboxed, so that's very. No, it is boxed. Sorry, which means that it is low.
you
But
know what I'm saying, right? If you have something that shouldn't actually consume that much power, which is like comparison of like a record, let's say. If you have like I don't know 10, it's already heavy. Like if it's a big record, I mean.
mhm.
It's because you have the trade-off. Either you sort always on declaration, and then you just trust the rest of the program, right? Or you sort everywhere, and then you are sure that you don't have like some invariants like
Yeah, he's
in
correct. We need to
blocks
choose
or
where we're
something.
gonna trade.
Yeah.
You could do something interesting,
You have to pay
right?
attention.
You either have dependent types, and then you say that,
I was
okay,
about to say
this
that.
type can only be created if it's sorted. You
Uh-huh.
see?
Wait, before you continue, can somebody remind me why we are using lists rather than map
In where?
in here instead of having a list of fields for the both anonymous and nominal?
Why are we not using sets?
Yeah, that's the question. No. We are not using sets because we need to save a key to something. That's always the case.
A set of tuples.
Yeah,
Yeah, a set of
the same.
tuples.
But
It's
yeah,
just
that would be the fucking map.
Yeah, okay, yes.
yeah. So why
And
we
I
are not
think that,
using map?
and we don't need to sort on a map, right? We're
Yeah,
kind of
we don't need to
stupid.
sort.
We're
Do you
stupid.
have the equality to maps?
Yeah, I guess so. Let's double
Working
check
as you
that.
want?
Hope we have.
Yeah, it is the equal of both the key and the value.
Okay.
So is there a special case that we need to care?
I don't think
Dude,
so.
I would just say,
If you declare the same field twice, that is possible, I think. You declare the same field twice, and then it just replaces by the last one.
No, but this is also
wait,
this is will also be the case because when we are parsing, we would be folding a map, and the insertion of a map always
No,
preserves the
yeah,
last one.
I'm saying like this is a thing that is wrong, but I don't think it is because of this.
wait, what are you saying about the parsing in the map?
I'm saying that
And
uh,
a block.
When
Yes.
parsing what?
when parsing whatever is a record, we would be gathering all the keys and the values in a
Wait,
in a
that's not the
Yeah,
parser.
that's a problem.
That's
why.
not the parser, right? It is on populating the fields on the environment. Oh, yeah, okay, it is the parser, right? We just see if it's equal to
Yeah, but
something
Nathan
else.
said that we have a problem, so go.
Yeah, if you are doing that on the parser, then the user, you would write multiple fields with the same name, and you would just, oh, that's okay.
Yeah, no, the user will never know.
Yeah, that's what we're saying.
That's But dude, like, the safe way is using the list there, like for sure.
I don't know if I would consider that to be a safe way, but okay.
You know how it behaves for sure. At least more than you do with the map.
We
No,
hope
I'm
we
pretty
do.
comfortable with maps as well. I don't know what you're talking about, but okay.
So you saw the implementation of the map.
No, it is both. It is the
No,
implementation.
implementation.
Nathan is becoming Richard Stallman. If you haven't seen the code, you cannot trust it.
That's fair. So Nathan is talking about the implementation of the map.
Yeah, how are they doing the equality, like? Or at least, is there some piece of text that like describes the equality of the map?
I think I'm pretty confident it's just deriving, but okay, let's see.
No. The thing is, you derive the map. It has the equality. You know that it requires both the value and the key. That's a good indication. But you don't know for sure if the equality is what you want.
But we can test that.
I guess you can, kind of, because again, tests. So you only are checking a few samples. You still don't know the general.
No, yeah, it's in here. So the equality of both the keys, the equality of both members of the quote-unquote tuple of the map, they're gonna be equal if the sizes of the map are equal and if the two ask lists converting.
Is that a sorting function?
Yes, this is a sorting function. I'm pretty sure.
So yeah, it does what you are doing.
To ask list. Yeah, so it lives in here. Converts a map to a list of key value pairs where the keys are in ascending order.
Wait, converts.
Converts the map because this is a map.
Oh, it's just because this is an int map.
Just try, man. Just try, please.
Yeah, then that's doing exactly what you're doing.
Yeah, so later on, I'm gonna put that to do here. because having a to do is you have higher chances of remembering later.
Higher
So
chances. That's
to do,
really weird.
we should remove lists from records
There was
and
a tool that
just use.
picks to-dos and can create like a.
This is a Zosing 2. That's what you're talking about.
No, that was another one. I remember Nathan showing me this. It was a JavaScript garbage.
What? A two for what?
Oh, dude, like I
Yeah, you
I
didn't finish the
discovered
sentence,
something
Magita.
today.
I got it before you finished. Sorry.
Man, the JavaScript ecosystem, like it's so
Wait, Magenta, what are you
holistic.
talking about? I'm not.
Picks the to dos
I
and
know.
creates issues, I guess.
Oh.
But here's another thing. Like I was looking today with Benet, and we were installing on the other guy there work, like a tool we need, which was like for pro buffs. And then the thing is like a Go binary, so it's like portable, right? Uh, but then like the way you fetch the thing and install and everything, they made an npm package, and they
Because
literally
it's
host the
easy
thing
to
in
distribute.
npm. Dude, they literally, dude, think of this. Think
Mm.
of think of how promiscuous this is. Like you're literally hosting a Go binary in a JavaScript package manager, and the community doesn't care, man. Like
What
they
is
just
the point? It's accessible, man. No.
what the heck, man? The community doesn't care. It's not a JavaScript package. No, it is a Go binary, and nobody complains.
Dude,
Dude,
that's not a problem.
it's a feature.
But no, you have the library there. It has either libraries or CLIs, right? It doesn't matter what the CLI is written in.
Look at this to do.
And let's sort by so we can have a record value equality.
Hmm?
Oh, okay.
Yeah, so another reason to have the map. I
But
Man,
don't
we are
get.
yeah, the
gruggy. How
only
did we
reason,
think of this before?
Sorry,
yeah,
repeat, Magit.
We are so gruggy. Like, why didn't we think of a map before?
So good.
yeah, the only reason I can think about it is performance. Besides that, I don't think the list is better than the map in any way.
No, I think that the list is worse in every possible way.
I don't see how the list is better. We have to do sorting. We have
No,
to
no,
do
no,
garbage.
no. Well, it's better in the way of performance because, as I said, you do the sorting on declaration and never, right?
Dude, I don't
But
think
But
with the
then,
I'm not
map,
no,
even
no,
you
caring
but
do
about
then,
on
performance.
every. No,
My
no,
point is not even performance. I couldn't care less about performance. My point
no.
is
I'm saying it's better, not that you care.
no. I'm just saying it is easier.
no,
Like you
and it
don't need
is
to keep
faster. I don't
thinking
know
of
what Nathan is
order.
talking about.
No, it is, but that's out of the point. I mean,
Wait,
like
what do you mean by insert? Comparison, dude.
yes,
Oh,
if it's a map, you can
comparison.
just compare.
No, no.
No, no, but he's saying that the comparisons is not performant. That's what he's saying, Magit.
what I'm saying
But
is
it's
the
easier. That's what I
list.
don't, dude. That's what I'm saying. I
Okay,
don't care
it's
about the
easier.
performance
That's
because
okay.
everything is already shit.
Sure, okay. I'm just saying that the only difference that I can see between the one and the other, like regarding those aspects, is the list is better performance-wise. You only sort once. The map you do every time you do the equal.
Yeah, but it's easier. You don't have to remember.
Well, yeah.
You don't have to trust that you did a sort by as well.
Yeah, that's pretty annoying.
And it's
Values.
already slow, man. Anyway, who cares?
I don't know about being the slowest thing ever. I think it's gonna be
Which
faster than
thing is?
Erlang, for
Okay,
instance.
let's try to do like a
No, you are
scientific
kidding,
competition in Silverware.
Leons.
I'll
It's
be
gonna be
back. I
faster than
have a,
Erlang.
Yeah,
uh,
that's totally bullshit,
so
Leons.
that's a very bold claim. I'll be back.
I'm not saying it's gonna be faster than Erlang in every possible implementation. I'm saying that in our implementation.
I mean, I would be really, what can I say? Well, I think it's very unlikely we are faster in anything.
That's fair. Uh, wait. Oh wait, this is a dumb way of doing that. Hold on. Yeah, dumb way. Okay. So let's make this better. So as far as I can tell, it's gonna be compare on first, and that's it.
Wait, what was our solution last time? It was even shorter than that.
Oh yeah, I remember you
Oh,
saying that.
wait. But that case is different because you have stuff inside it. Oh
No,
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 it's not.
it's not. It's not. Well,
It's the same. It's the
how do
same
we
thing.
solve it last time?
Wow, take a look on the commits. It was literally sort, passing a function, and the two things.
No, no, sorting passing a function. I'm
Wow,
pretty sure
yeah.
we did.
No, but I mean, it was sorting,
Oh, it's in here. It's in
function.
here. It's in the create binds. I remember that. I remember that. No, it's not that. Oh, it's here. So instead of doing what we did, where is it, dude? I remember it being very recent. You
Wow,
wanted to
it's probably
sort
on the
truth.
sum part, right?
Yeah. It's not this. Create binds. Label of constructors. What the
Oh,
crap?
start on.
Sort on. Sort on. Sort on first. Okay, so let's replace the by here. So instead of all of this, it's gonna be sort on first. First.
Oh yeah, that's nice.
Oh yeah, that's nice. And we can also remove this. And then in the evaluator, okay. Okay, this seems okay. So now the question is, we just need to parse that. So let's do that. So expressions, anonymous record, it's in here. Cool, 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 cool. And let's think how we want the nominal ones to be going.
Literally a strings before somewhere.
Nominal. Okay, so how do we decide we're gonna instantiate that?
Just put
Uh,
a name before the command.
a name before. Don't we have that in here? Oh, we do. No, it is different, dude. It is different.
Oh,
It is this.
yeah, it's just a name before the pipe. That's the only difference from the anonymous one.
Okay, let me grab that.
Oh, okay. Regarding performance, the parser is one of the worst performance-wise
Oops. Why?
because of the we do a bunch of look-aheads, right?
Hmm.
With this
Look ahead.
or, if they do part the same thing, you are doing look-aheads. For example,
Yeah, but we
you
avoid that.
we are not.
We avoid that. That's why we don't
No
have any
way.
parser that grabs two like predicate, like not predicates, two the same beginning of the string, and then we check that later. That's why we have so weird operators because we don't want to reuse stuff because we know we would have to do look aheads all the time.
Wait. I don't think we do. For example, let's suppose you have the expression, and then you have parser expression A or parser expression B. But both parser expression A and B starts parsing the same thing. That's doing look-aheads because of the OR.
No, probably the or has look aheads, but it's not in the way that you said it because we have to like we don't have to test if we have two beginnings of the string that are the same and stuff. I don't think we need to do that.
Wait, can you repeat that part?
Yes. So I don't think. Let me just double check a thing here because I'm getting confused. Uh, oh crap! I
They
made
are
them.
together.
Ah, oh crap!
That's a bit sad.
A bit.
Oh, and then they also cannot have space in between, right?
Yes. So the nominal one is only nominal is only this. Okay, I just finished this. So the thing that I was saying is that I don't think we need to do a lot of look-aheads because we don't have a lot of things that start with the same substring.
Oh, like it's not so longer, right? The substring of
Yes.
stuff. Yeah, I guess so.
Okay. Okay, now we need to go to here. Anonymous. Oh crap, I changed the wrong one.
What happens even if they have the different beginning? Like, is that still an overhead? Because I still have to go through each one if mine's like the last one to match.
Wait a sec. Uh, skip. Then we're gonna put variable generic. And this is only the first one. Then we're gonna have a many of expressions. Many of expressions. Many of expressions. Does that make sense? Wait a sec. How we are parsing this?
Be right back.
String skip many. Oh, this is an arg and. Oh, okay, I see. And then skip. And then we're also gonna pick the char. Yes. How are we doing this? Okay, so it's not exactly that. It is this. Yes, 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 yes. So this is gonna be nominal. No, this is nominal. And this is anonymous. Yes. That is indeed what we want. That is indeed what we want. Okay. Actually, I'm gonna just comment those out. Record P. Okay, types. No, actually. You need to declare that you need to use a def record. So this will be record. Variable generic. That's totally okay. Where the heck we have the here? Utilities. How much time we have left? We have 10 minutes. It is possible. Oh crap, I copied it. I should have copied this. Yeah. very generic. Then we have the option there. Hello?
Hello.
So, question for you. Question. Our records, you will also be able to give parameters, right?
Yeah.
That makes sense. Then the question is, I think, if I'm not mistaken, I think that this is grabbing the names of all the parameters of the kinds of them. This is doing you're using nullary and p. Oh yeah, so this is basically doing a parser for grabbing the name of the thing in an empty set of parameters. Yes, and this is grabbing all the tags, basically. It's doing all the tags. Yeah, so this is for empty. We can't have empty in records, right? Every single name has to be uh, have on the side its type, right? Hello? Hello?
Wait, man. Wait. Uh, what is that parser?
I'm back.
I'm just asking if in our records
No,
you
no.
can't
What is
have
that parser?
which one?
What is well,
This?
the one that you are talking about?
Yeah, this is the parser for the definition of a record.
Okay, go on.
So after having the def record and having the name and grabbing the potential kinds that we can have there because of the parameters, my question is, always every single field of a record needs to be side by side with a type. Is that correct?
Yeah.
So this doesn't make sense. Great. So this is every single, actually let's not call it a tag in here because this is not an ADT, this is a field parser. Yeah, after having the field, then you're gonna just grab the tag, like that, and like that.
What is
Oh, you are not using the alias. Sorry.
Yes, I'm not
what
using
is
the alias.
what is this tag?
Which tag?
This tag p.
Oh, it is not anymore. This is the field p. This is a parser for many fields. Then we're gonna call these fields. And these we already have the data. We have the name, we have the parameters for the thing, and we also have the fields themselves. So now we just need to make the data type. So this is gonna be declare type. The T will not, it is a maybe algebraic. Okay, so this is if this is nothing, so this if this is nothing, sorry, we're gonna use this, otherwise we're gonna use this. And this is using a fold which uses the fun. Yeah, that makes sense. So what we need to do in the case of ADTs, I copy pasted the ADT. Okay. So what we need to do, what is the base case? Is when a record doesn't have any sort of parameters, right?
Yeah. Wait,
Yes.
what is the algebraic there?
No, this is a copy paste from ADT, dude.
Yeah, I'm still asking, what is the algebraic there?
Okay, I can explain. So the T algebraic needs to have two situations. The situation in which you don't have any sort of parameters and the case that you have. How you differentiate those? You use this.
Oh, okay, it's your initial thing, right?
Yeah, let's call that, that's a good name, initial. No, not that, this, initial.
How does the folder calls it, man?
And this, let's call it type prime, and this is gonna go here. So this type initial is gonna be T nominal, and then the name. And then, is it possible to have a record without any sort of fields? I don't think so, right? Does that make
No,
sense?
No,
no.
No, right?
I hope it doesn't.
Maybe in Python you have like empty tuples.
Maybe in Python. Yeah, so if that's the case,
There are no tuples in Python, by the way. It's just a list.
Wait, there's something wrong. Wait, no. Wait.
No, like I'm saying, like tuples in Python, they're just lists.
Are they? You mean implementation-wise?
I don't know in the implementation, but they act like the same.
That is
They're
no
just
way.
different. You can iterate them.
there
You
is
can do
no way.
everything.
Okay, you can iterate them.
Oh, okay, I see. So the base case is when you don't have any sort of parameters, because then we
Can
don't
you
need to
access
construct
them
this.
by indexing the same way?
Yeah,
So this is gonna be this.
they are the same thing, man.
Issue.
Yeah, so far,
At least not that I can remember. Maybe it changed because it changes every week.
Administration name. Time. Is that it?
I,
I
can
am.
you do the pattern matching lists? In Python?
All of a sudden, Nathan is 100% interested in Python.
Oh, he just said that in Python tuples like behave as lists, right? So I know you can do the pattern matching on tuples, right? Can you do it
no,
in lists?
I haven't used Python like since last year, I guess. Thankfully.
P. Wait, I guess we are good to test. I'm surprised. This was fast. Okay, so let me
Oh, you need to
explain.
evaluate stuff, right?
What do you mean by evaluate?
Have you done the evaluator part?
Yeah?
Really?
Yeah.
Oh, then we are done.
Okay, let me explain the parser just to see if you guys can grab a mistake that I made. The
Okay.
first thing that we do is that we just remove the bracket, the open bracket, and the def record. We get the name. Then we get the potential parameters for that record, right, with their specific kinds as well.
Mhm.
Then we make a parser for in a field, a single field, which is basically a name and a type, and multiple types actually. Oh, that's something we need to discuss. In the records, we can't have multiple types, right?
What do you mean by that?
It is because in
Yes.
the ADT you can have multiple stuff, remember?
Oh yeah, you want to have one.
We only have one. So this is not many. Yeah. 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 So then you grab the name, you grab the type, and then that's a field. Then you're gonna parse many fields, at least one, and we're gonna close the bracket. And then how we differentiate between having parameters and not having? We use this maybe function, because if this is a nothing, that means that the record doesn't have parameters. So then we just return the t nominal record, the name and the fields. But if we have some parameters, we just fold, putting in the beginning a bunch of t abstractions.
Wait, why do you have a maybe? Why isn't named kinds just a list and then you don't have branching? You always execute the folder if it's an empty list. The folder will return the initial already.
I don't think I got the question, yeah, but if I got, I think you're misunderstood. Okay, so let me explain why we need the maybe, okay? So the maybe is because you may have records without parameters.
You may, okay.
If that's the case, this is nothing, because this is
Can
optional.
you show me the syntax for it?
Sure,
With and without the parameter?
sure. So let's go to types. Let's do Control Z in here. Yeah, so this is without. Okay?
Okay.
Now with. The one with is like this. But let me put it here. So it's going to be record, right? Then it's going to be person. Then it's going to be name. and then it's gonna be age, and that's it.
So it is optional because of the brackets, like the square brackets?
Yeah.
Okay.
Okay, going back. So then, if we do have them, we fold the abstractions exactly as we do with ADTs and alias, which means that this process may be better abstracted out. This is the third time we are doing kind of the same thing.
Yes.
Anyway, so that if that's the case, we just fold it and then we just make a declaration of a type using the same name that we used to make the record. And we pass this type here, which does the branching, like if it's initial or you need to put the abstractions in it. And I guess that's it. We are ready to test. So I'm gonna grab this.
Have we done the kind checking?
No, we didn't do the functions that interact with having extra types. That's a good call. Let me just add the anonymous, and I'm gonna add nominal. Okay, I'm gonna just save it here. Now we need to do the stuff that is related to what you said. So we have 4 things to tackle: type substitution, reduction, kind checking, find the alias placeholder. So let's start with the easiest one in this case, which I think is going to be the kind checking, because I think it's going to be exactly the same as this, because we already know it needs to be star. What you say, Nathan?
I think the implementations are all the same, like for the ones we have for the anonymous record.
Cool, done. Next, reduction. Where is reduction? Here. So how we are doing that? We are just, for the anonymous one, I mean, we are just grabbing the fields and then we are mapping the reduction. I think it's gonna be exactly the same. Does that make sense? Oops.
Yeah, I think that's for all the cases.
Okay, 2 more to go. Find the alias placeholder. Here. What do we do when you have to do a find placeholder with an anonymous one? We just call the function recursively, doing the so beloved unzip and zip that Nathan loves.
Also known as map. That's exactly a map on the second one.
Also known as a map.
What is the difference? The unzip is kind of safe. Type-wise.
Okay, I'm doing exactly the same. Lastly, type substitution, which is here. So what we do for that with anonymous ones? Oops. We have a name. We basically have map. Yeah, it's gonna be exactly the same, I guess. And that, and that. And that's it. Okay. Let's see the errors now. How much time we have? We are 4 minutes extra. That's cool. Okay, a lot of things broke. That's unfortunate, but let's go one by one. So 168 on evaluator. 160. Oh, I changed this. That's cool. I did change this. So we need to change the projection and the updating process.
Oh man.
Okay, so if we have a name, what we do for projection? I forgot. Projection is the getter, right? I believe so.
Yeah.
I believe so. Yeah. So let's see.
It's just the same thing, like literally copy and paste.
Wait, with and without a name is the same?
Yeah.
Okay, so this is just wildcard. What about updating it?
Oh wait. Oh, that's the FO. Oh, okay. Yeah. Ah. But have you done the type check of the projection?
I am very certain that we did. E-record projection. Yes.
Yeah, but not adding the new one, right?
Oh yeah, we need to do the adding this another case. So type checking of a projection of a nominal record.
And then that's literally you don't even need to bind the record name.
Oh, it is the same?
Oh yeah.
Okay. Is it the same case for the evaluation?
For the projection, yes.
Updating it.
Well, for the evaluation, I think so because we are assuming everything was checked, right?
Yes. Okay, so we need to also do the updating for the record update type checking. Sorry. So
Yeah,
what?
that might be different depending on what we did there.
Okay, so let's see what we did. We did for to update list. To update list. What is to update?
What the fuck is that?
It's in here. Okay, so it's a list to update. Okay, that makes sense now.
What is the type of to update list?
It is e-record update.
Oh, you don't have the
Uh,
hint.
e-record update. It is a list of tuples
Oh,
in which we have a label and an expression.
okay.
Okay, so let's go back. So we grab that list and we type check it and reduce it. Then it's gonna be two updated types. Then we grab the fields, we transform them to a set in order to make sure that they are not, they don't have repetitions, I guess.
Wait. Where is this coming from? This is coming from.
This fields comes for this, and this to update list comes from the update.
Oh, we are only transforming set because we probably need it to be a set for the type check, right? We don't, yeah.
Then
That's not for removing thing.
Okay, so then we do an if to see if the updated types, if this is a subset of the set of fields that we just created from the fields. And if they are, we just return. So what do you say?
I'm updating are just a subset of the. Yeah. Ah. I suppose that's doing correctly the equality of the.
Mm-hmm.
I think it doesn't change in anything then. Yeah, I think it's okay. It would only be different if on the anonymous record we. Oh, wait. Yeah, if on the anonymous record we had an option of all, well, of besides updating, also extending, right?
Yeah,
But
no,
we are
but
not
we're
doing
not
that.
doing that. We're not doing that. Next error. Wait, I didn't save? Evaluate. Oh, I didn't save. Okay, next. So 155. It is a sort on value. What is this? Oh, this is wrong. Okay, next. 181, map to list. 181, map to list. Oh, okay, we also need to make sure the projection and the update are correct now, because they are not. Okay, so this has maybe name, and I'm gonna just put maybe name here.
Wait. What do you mean by maybe name?
This is a maybe name.
Why do we have the name in the value?
To print the record with the proper name if it has one.
When would you need that on the value?
Now let's see, this is an update. So we are probably recreating it. Yeah, we are recreating it from scratch. Yeah, so you have a record with a name and its, well, potentially a name and its fields. And we are just recreating it with the updated values, like immutability or whatever. And we need to use the same name as the original one. If it has a name, it can be anonymous or a nominal one. Next.
Yeah, I think that's totally not a thing, man. You
So
only need that
55.
to type check, I guess.
Well, I added to be easier to identify when printing. Anyway. Oh, this is wrong. First, this. It's getting worse. The zip is getting worse. Cool. And I'm guessing this will also be the case on here. Yep. Next. V record 49. 49. And then we have a name. So maybe name. So let's put what? Record. Maybe I don't know. Unpack X like this, and then maybe name, and then that. Okay, now only parser problems. I'll even try to read these. I'm gonna just YOLO it and read myself. Okay, but I want to know which one. Nominal, only nominal. Oh, cool, this is the last one. Oh, also, I forgot. This printing needs another thing. Let's put nothing. Okay. Okay, now only the parser will complain. Oh yeah, the typer also is complaining. 163 typer. 163 is not an import issue. Check existence. Check existence 182. What's the problem? Oh, I'm not passing the env. I'm dumb. We only have 3. I saw something red. Yeah, this is the parser stuff. That's okay. Yes. Okay, so now only parser stuff. Notice again the nominal record. A label and a field. Okay. Okay. I'm not with that much patience to do applicative style, so let's put like then do like this. So it's
You're
gonna
getting
be
practical.
I'm getting maguetas. That's what I'm doing. This, yes. Then that. Skip variable generic there. That's cool. Fields. It is this. And then this name fields pure. Next. Okay. Now let's make an example. Magetta. Let's start with something a little bit easier. So let's not do this. Oops.
Okay, you're gonna comment.
Yeah, so I'm gonna comment this out. So we have a person, which is very fair. So let's make functions and let's pick the anonymous record example. I think it's a good one. So instead of doing all of that without names, let's do that with names. So let's say that XYZ, let's say this is a person. So I actually don't recall, can we, yeah, we can. We don't have to put a special syntax in here. Cool. So then we have a let in which we are replacing, let's put name with, I don't know, yeah, it can be wow. And let's pick the age and be 104. And then here we are getting the number, so this is age. And then here we are getting the, I just noticed that this is completely, no, now it's better. We want to see the previous age as well, and we also want to see the name of the first one. And now we just need to create a person. So person, let's put age 130 and that name. And I think that's about it. Let's see what we get. This, a nominal record SW. Non-exhaustive patterns in function show. Oh, we need to show how to print that. That's true. Function show of types, probably. Yep. So nominal. Yeah, but in the case of the nominal record, and we're not gonna put this. We're gonna put the name itself. So it's gonna be. Wait, what? Oh, there's a function down here. That's why.
What's
So
the application, by the way? The application is... wait, we have something weird with the application, right?
application. What do you mean?
Yeah. We will have a bunch of pipes, right? Instead of
No, we
only...
already have. You didn't notice that yet?
I never saw you print an application.
I think we did once. It was pretty bad. Okay, so how I want to go about this? I want to go pipe this, then unpack the name, then give me that. Yeah. Then we have the go, filled with the type. Cool. So let's build it again.
Oh, I think our printing, well, besides the pipe, is very good already on printing like generic records, man. Like you have person that receives A, and then he can like print correctly, like person int or something.
Type mismatch between parameter of type name and argument of type. Oh, the order matters.
Where?
It is saying here, type between parameter of type the name comes first and then the age comes later, and then down here the age is coming in the beginning and the name later.
I can't read that properly, but yeah, then we are forgetting to sort somewhere.
Okay, so it is a type error and it is a type mismatch. So type, oops, type mismatch. Mismatch. Not in here. In here. Okay, so the reduction of them are not the same. So we are forgetting to sort somewhere, which leads me to believe that we need to sort it again here. Even though that doesn't make sense, I will put it in here and see what happens. How is that not sorted? Huh. How is that not sorted? The same. It's exactly the same, so it's not a lack of sorting there. Okay. Okay. Let's print it then. Why not? Print reduced saved fields. I don't know if we have lift.io in that module. Oops. Oops. Maybe we don't. Maybe we do. We do. Cool. What the? Okay, so I don't know what's happening. The reduction needs to be wrong then.
What are you printing?
I'm printing both the things that we are comparing before doing the type mismatch.
Wait, what are you comparing? You are
Oh no,
comparing the
no, no,
one that
I
got
said
from
it
the
wrong. I
end?
said it wrong. I said it wrong. This is not the correct one. This is between parameter. This is between record declaration. So it's not in here. So it's another type mismatch message that we have. So next, next. It is in the e application. It is in the e application. What the actual fuck? What in the actual fuck? Yeah, it needs to be this one. Okay, now I'm curious. What is this?
Just a sec.
We are looking for e-application. Okay, so there is an e-application here. But I think we are looking for an e-application. Print record. Oh, I know. I know. It's the map. If we had the map from the beginning, it would not occur.
Are you doing zips?
No. Look, dude,
What did...
I am creating a person in which the order is age and name, right?
Uh-huh.
And the type that I am declaring in the beginning is name first.
Sure.
So
But
what
if you are sorting the declaration and the type check
are we
of the,
sorting the declaration? I don't think we are sorting the declaration.
take a look on that.
I'm almost sure.
You are
I'm
sorting.
back. What happened?
We discovered the well, we are close to discovering the problem. We are not sorting the declaration by any means.
Yeah, you sure would not do that on the FRC. So on the type check of the anonymous, wait,
No, it is not in the type check of the anonymous record or the non anonym or the nominal record, I guess.
no, yeah, there we are sorting the thing we get from the aim, right?
We are sorting get from the env. Yes. No, it is printed here. One of them is coming from the anonymous record type checking being reused, and the other one is coming from the environment. Both are sorted already. The problem, this error only happens if you have an E application, because it's saying type is matched between parameter of type, and the only place that we have that is in here. So the parameter type and the reduced archetype, they are not the same. They are not the same.
Yeah, I guess the yeah, I guess the only way is either sort on reduce or indeed in the parser. Would not be that bad maybe.
Wait, but I'm
Because
confused. Why we are getting this problem then?
yeah, because when you are comparing the thing you annotated with the thing you actually got, the thing you annotated, he will get from the context, right? And
Yes.
then he will get in the order it is. So you either sort before putting on the context on the parser or doing the checking, the equality, right? So the reduce.
Oh, you mean sorting in the reduction?
Yeah, either on the reduce or on the parser.
I think it's worse in the parser. So we need to sort it in here, I guess. So it would be something along the lines of sort on first in both.
Dude, reduce is doing way too many things. It's doing at least 3 different things.
Yep, I have to agree.
He's applying functions from types to types. That only thing he should do, really. He's fixing the sorting of our record types, and he's also unwrapping type aliases.
Reduce? What do you mean? It's not a reduction.
Well, if you want to stretch the reduction meaning of the word, yeah, I guess.
Okay,
That's
but which are
forcing
the
a bit.
places that we can remove sorting then? Oh, dude, but that's bad. That's really bad. Because sometimes you want to do the sorting, but you don't want to do the reduction.
Like
Like in here, type check expression of the anonymous record.
type check
We
expression.
want to we want to sort it, but we don't want to reduce it. So I can't call it. I need to call sort explicitly. That kind of sucks.
Oh, okay. You were just telling that because you wanted to substitute the sort by the reduce.
Yeah.
Yeah, that's bad in many ways. You can't reduce when you want.
Yeah, you need to accept both. The reduction needs to go type alias unwrapping, sorting records, and the reduction itself.
Yeah, but only before comparisons, right? You can't just call it reduce, like just to sort. Even if you could, you shouldn't.
That's fair. Okay. Time mismatch between rocker declaration and instance. Okay, so this is happening because maybe I removed a sort that I shouldn't remove. Okay, let's double check. So this error is in here. So it is in this if right here. So these two guys are different, but I don't understand how. I don't understand how. Don't understand how. Don't understand how. No, 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 no. Wait. Yeah, I don't understand how. That's for sure. The saved fields, it's a list. Oh, I need to sort this guy. Yeah, I can't remove it from here. Because this is a list of tuples, this is not a list of types. Oops.
Okay.
I'm thinking maybe.
Yeah, man,
Well,
using a map, not using a map was so Greg. Holy fucking Jesus.
yeah, the only situation you could really know without overloading the reduce or the parser, if you are still using a list, would be to have a different declaration only for records.
Yeah. Okay, so let's read. So I'm passing 123 and yay. And the first thing that I do is to create another record doing a set. And I'm changing the name to wow and the age to 104. I'm printing the age, that should be 104, that's cool. And then I'm printing the previous age, which should be 123. And then I'm getting the name of the updated one, which should be wow. And it is indeed working. Okay, so now the problem that I just figured out that we had, that I didn't think about. Ah, man. Okay, so there's a problem. There's a very, very cool problem. How are we gonna instantiate a record that receives parameters?
How we?
How we gonna instantiate a record like person, but we are using this person, right? What if I want to comment this and uncomment this? How I'm gonna instantiate this? My guess is that we would be using something like we did with the list one, so string integer, like that.
I totally forgot about that, dude.
Yeah. And more importantly, this function also needs to change, right? Because this will now have to be string integer.
Yeah, that's very interesting, but also very easy to solve. Uh, oh, wait a second. Mm. So, yeah, but that was also because we were a bit dumb thinking about it.
Oh, no,
Uh,
don't you tell me. We
yeah,
were dumb.
we were dumb on the string part. The annotation that we have on the record actually needs to be a type.
The
What?
annotation on the record needs to be a type.
The
Yeah.
annotation on the
I didn't get
record
it.
needs to be a type. What do you mean by annotation on the record?
You have the name person on the record, right?
Yeah,
And that's a string.
yeah.
I guess it should be a type
Why?
because that is a notation, a proper annotation.
We are not doing that. Are we doing that with the ADT?
Well, no, because we don't need to, I guess.
But we do need to. What do you mean?
Oh, okay, yeah, but the ADT, they are functions, and then the thing is, they are functions that also receive types, right?
Oh, I see. Holy crap. Okay, so this is because we are not treating the record, I guess, constructor as a function as well.
Because we can't.
Explain to me. I didn't get it.
I can explain. So when we did the ADT stuff,
Hmm.
we chose to pick each of the. Well, let me go from the beginning. Why we don't need that limitation? Why we don't need that thing that Nathan said for the ADTs, right? For example, in this example here, right?
Mhm.
Because when we are parsing ADTs, this is a type. This is not a name, right, Nathan? Am I saying crap? Just a sec. Just a sec. Oh, name and type. Wait, now I am confused again. Go on, Nathan.
Go on with
Definition.
what?
Why do we need to treat that person as a name and not as a type and not as a name?
Because what is a type annotation, right? It's an expression and a type for it. You check if they match. If so, you say the type of this whole thing is the type annotation type.
But are
So,
you calling the name of the record and type annotation?
because it needs to be if you want to do the thing with the, how do you say it? Uh, oh shit, that's something very interesting. Yeah,
Everybody's.
yeah, that is still the case. You need that if you want to do the application of the record, right? So you need that. But the thing I thinking is, dude, it. I don't even
Oh,
know
we
how we
need
would do
that.
the in. Yeah, I don't even know how we would do the inference
Okay, I can
of
explain now.
generic
I can
records.
explain now. Mageta, look at this. Do you agree that when we have, where is the list one? Where is the list one? List. At some place we have the list one. Oh man, where is the list? Because the list is that exact situation, right? The list, we don't consider the list to be a name, but we need it to be a type in order to do the type application stuff, right? Because we need to insert something in the list stuff. It is
Yes.
the same case with the record. We need to insert something in here. But
Yeah.
if this is
Okay.
a name, we can't.
Mhm.
And that's the problem. I don't remember how we did the list though. Where is the list one? I completely forgot about doing how we did the list. List. No. No. Okay, I forgot where is the list one, which is not good. So where are we using that list? Yeah, list integer. So let's try to see how is that being parsed. So list b. Okay, so wait, e-type application of this. Okay, so what is this thing then? What is the thing between pipes in the type level? Any type application needs to receive a type, right? Type application. Yeah, this is a type. So which type is that? Let's see. That type is a T application. A T application receives a type and a type. Yeah, so the list needs to be treated as a type. So that means that the parser, so the record also needs to. What does that
But the
mean?
thing we solved with the list wasn't we put it on the context of function that receives a type and returns that type inside the type of the list.
Oh no, wait, you're right. The list is here. We have a T list thing.
Yeah, I remember.
Okay. So yeah, but I still don't recall how we are parsing that thing.
Oh, we are just parsing as everything we are parsing as alias, right? Check our environment. If we have an environment with
I
that
think we
type,
both refactor, right? I remember.
yeah, but haven't we done that?
Yeah, the list is here.
Yeah, so you are the.
Okay, but then okay, so how are we gonna do that with records?
I said like a type instead of string.
A type instead of a string. A type instead of a string. Wait, I'm confused. Let me think about that.
Wait, yeah, a type, yeah, a type instead of string.
Wait, what is gonna change in the AST level? Nothing? Hello?
Oh, wait a second.
Okay.
Can you go to the expression?
Yes. Here.
Yeah, it changes that. It's not a label anymore.
It is a type.
Yeah.
Okay, so what is going to be that type? A T variable? T alias?
Well, as it says, it can be any type.
Yeah, it can be anything, but how are we going to treat that?
Yeah, but when checking that, we will match. Yeah, if that it's a record, right?
If it's
After
a...
reducing it, if it's a nominal record,
But it can also not be a, nominal record too. It can
then
be a
it's
T
a
abstraction.
record.
No, that's not the case.
No, it cannot be a T abstraction because we will reduce it right before matching.
Oh, okay, I think I see. So what you're saying is that we're gonna go to here, and instead of doing name, no, everything started because of that. No, but we can reuse this code, I guess. We're just gonna have to do T type this, that, then case type prime off. It needs to be a T nominal record.
Yeah, but you need to reduce it first.
We need to reduce it first. Reduce type. Okay. Okay. Wait, so you're gonna have the field in two places then?
Wait, we need something else, right? Don't we need to do something before the reduce? Like
It's because
the
usually we type
find
check before
placeholder
we
80?
find place. This was already. Wait,
On every time that the user types, I think we do both, right?
no.
Find alias placeholder and reduce type.
Yeah, we
Check on
do
that abstraction.
abstraction. You mean E abstraction?
Yeah, and also we need to kind Oh, shit.
Yeah, that's what we do. We do the find.
So what we do is
Let's copy all of this
define
code. Let's copy
the
all of that.
kind. No, it doesn't make sense to copy all of it, man.
No, it kind of does because we're gonna have
Oh,
to do.
to comment and take the part, right?
Okay, so the first thing that we do is that we pick the type, we find the alias placeholder, then we kind check that. If the kind is not star, we throw an error.
We don't need to match the kind. We can just discard it
We don't
because
need to
matching
match
the
the
record is enough.
we don't need to match the kind. So why are we gonna kind check it then?
Well, to see if the application is correct, right?
To see if the application is correct. Wait. Dude, I'm so confused. How's gonna be the syntax of that? Sometimes you're gonna have the pipes and sometimes you're not gonna have that?
What do you mean?
Yeah, because take a look on the example here. So let's suppose that you are using the person that is up there, right? So it's not parametric and whatever the crap.
Wait, why do you need those extra pipes?
Because we are applying. No, I'm not saying that we need. I'm saying that this is the thing that we did to make the list. So I'm just following the same pattern.
No, we don't have that anymore, I guess.
We do.
Where?
In the example that we already showed that it worked.
So that's a ring.
No, but that's not what I want to know. I want to know like how is going to be the syntax of that? It's going to be like pipe like this?
I don't know what you mean, man. Like that's just a type, parser type.
Suppose that we are not using the parametric one, because the reason we need to transform the person from a label to a type is because we want to have the parameters here. That's why.
Sure.
So my question is, how that's gonna look in both scenarios? Because we're gonna change we already changed the SCT of the expression to be type
Okay.
instead of label.
So you need to parse a type, right? So that inside we can't change. We use the parser type to parse whatever type there. What you do around that doesn't really matter.
Okay, so this is gonna be a type. What is the name? This is going to be type alias. That. Is that correct?
Yes.
Okay, so then it can be without the pipes.
Can
So
you check on the parts, like, where's the situation that you use the pipes? Because now I don't remember. Like, is it to say that this is a type in an application? Or
probably because we have the pipe here because of the left recursion stuff.
type?
Because it was before it was the opposite, right? It was type and then piping, like passing the parameters to the type constructor. But because of the left recursion, we put pipe in the beginning.
Wait, but yeah, so maybe we have in two places? That's...
Two places?
Oh! Yeah, like we use that to say it's a type application, right?
Yeah.
But, oh, we use the bank to say that an argument is a type, right?
Yeah.
Oh, okay, I see.
Okay, so let's go back to what we were doing before. So my question is, you said that we do not have to check the parameter kind.
Yeah, I don't think we do.
And I don't know how that makes sense. Can you explain?
Yeah, because why are you kind checking? Because it could be an application, right? Of a record, a generic record, to some parameters, well, to some arguments.
Yeah.
We want to see if they are valid, right? Kind-wise.
Yeah.
So we are only kind checking because of that. But we don't need to know if it's a star, because we will match if it's a record, and if it's a record, we know it's a star.
Okay.
For it.
So then we don't need to do this pattern matching and this order also. So what we do after kind checking that?
Well, I guess reduce.
Reduce the, okay.
And then you can match and see if it's a record.
Okay, so we reduce it, see if it's a record. I have a question. We're gonna have the fields in two different places. In the nominal record, it's carrying the t nominal stuff that I'm pattern matching here after finding placeholder and kind checking. And we have the fields here, and we're also gonna have it here?
Wait, you are saying three places?
Two places. Two places.
Two places?
Yeah,
but that's what we need. We need to compare the expressions and the type. So that's right.
we need to compare. Wait, can you
Like,
repeat that?
yeah, you are doing an expression and you are notating with a type.
Yeah.
So,
oh, okay, so these are the provided fields that I am using to instantiate, and these are the ones that I'm getting from the environment.
like from the annotation, right?
Yes. Okay. So these are the annotated fields. Okay, so then if we pattern match that, then we do all of this. Right. If we receive something else, this is an error, I guess.
For sure.
Okay. So
What is that operator?
that
What
is
the
the
heck?
operator called typo.
Oh shit.
Means
I got scared for a second.
That would be a whole new level of Haskell.
expected type.
Right? That's what it means.
Expected type. Record type. But got this. Okay.
To finish this.
Yeah, we do. Okay, so now the only thing that we need to do is... Oh, okay, we need to also change the evaluator now. Change the evaluator.
What?
Because we don't have the name here anymore.
Well, we don't need the fucking name.
We don't need the name. Wait, we don't need the
We
name?
don't need it on the value.
Evaluating, we don't, right?
Yeah, we don't need the name in here. I have to undo all I have done then. Oh no, but I didn't like this because of the error messages. Now I remember.
Yeah. I
Now-
don't think we need that. at runtime.
You don't think we need that at runtime?
Yeah, like if you need to print as a message in an error, like it means that something really bad escaped the type checking.
I agree, but well, I like to be like this would help us debug as well, but I don't know. Maybe I'm being too
I'll,
pedantic about it.
I'll not say the word.
No,
I'll just
you
say
guys are being the pragmatic ones. I'm being the one more safe.
No, wait. No, that's the opposite, Leandro. That's the opposite. If you don't have a reason to have, but you just want that because, well, it's easier.
No, it's not easier. It helps to debug. It is easy to
No, but
remove the name altogether. That's
okay,
easy.
so if in theory it doesn't make sense, but I will do it anyway because it makes easier, that's the pragmatic side.
No, but that's not what I'm doing.
Mm.
What you guys are doing, it is the easiest way. Because you guys are putting everything you have on the type checking.
No, we are saying it doesn't make sense to have on the value. Like, that's the theory, right?
Yeah, I have to agree that that's a theory. So we also need to change the parsing. Because it doesn't make sense. No, this still makes sense. No, this doesn't make sense. Yeah, this doesn't make sense. Holy jeez. Yeah, we're gonna have to change this.
What's he complaining here? Oh, it's H-linked.
Yeah, it's how are we gonna fix this one now, Nathan?
Fix what? Fix
Uh,
what?
this is gonna be type P, I guess then. I'm gonna receive that. Oh no, wait. This is the wait. Wait. I'm very confused right now. Nathan, do you agree um, that we're gonna have to wrap this name in something else? It's gonna be what? T alias placeholder? Nathan,
Wait a bit.
you see the problem? Because before we were using the
Wait,
naming
that's the
surpluses.
definition of the record, right?
Yeah, this is the
Okay.
default definition if you don't have
What?
the parameters.
I mean, this parser is for the definition, right?
Yeah, this parse is for the definition.
Sure, what is the problem?
The problem is that before we are using the name for both the declaration of the type and the nominal record name.
Yeah, that doesn't change.
That doesn't change. This is only changing the expression level.
Yep.
So that means that I am in the wrong file. It's in here.
What the heck? Oh, I'm following you.
Okay, so this is not variable generic then.
Yep.
This is type P.
Dude, where were we? In the parser, right? But
Yeah.
which file?
No, expressions.hs.
Here.
So it's this, right, Nathan?
Yep.
Then we're gonna have the name.
Wait,
I mean, yeah, just change it here from variable generic to type P.
name.
Because now this is a type. Do you
Oh, man,
agree?
what the heck? I lost where I was, man.
No, you were in declaration, sorry.
Okay. Because I was editing something and then I was following you at the same
Oh,
time.
okay, sorry for that. Okay, so
And
what
then
are you changing there?
yes, that's the problem. I was moving parentheses and renaming because H-link was complaining.
Okay, so I think we need Control Z then.
Yes, there. Yeah, so this lambda here is useless. There it is.
Okay,
There's
move
these.
brackets to avoid that. Move brackets to avoid. Oh, he's talking about removing this. Actually, I don't like removing parentheses from many because the many
Yeah.
replace with.
I don't like to trust the precedence there.
Because
Yeah.
you know the precedence, that's why.
But I don't know every single operator precedence by head. Yeah, I don't know. Yeah, so let's see if this compiles. I'm guessing no. And
Let's
there's a
see.
bunch of it.
Wait,
So
what is the problem?
evaluator 50, printing stuff. Oh, it's because I removed the.
Okay, a
Uh,
second. Oh wait, you
no, it is
didn't
that.
put
It
a
is that.
space.
Oh yeah, there's a space. Next. There's no way. Yeah, there's no way. Okay, typer 251. Here, 251.
251.
This is a type.
Complaining about T.
Yeah, it is saying that T is expected a type and it is actually a label. Did I save the types? No.
In
What you
Rust, when
what you
you
got?
print a record, it has the name of the type, right? Well, the name of the constructor's
I
thing.
don't remember, dude.
Yeah, but they are cheating because they are using like metaprogramming, I guess.
They are chilling. Is that what you said?
Cheating.
Cheating.
I heard it, man. I just making fun of
Okay,
you.
so something that we changed broke everything. That's
Wait,
cool.
what?
Yeah.
Declarations line.
Oh, I think I know what
42.
you changed that you shouldn't have changed. Double check that.
Wait, declarations 42 is the line I was.
Yeah, this is not like this. This is this.
What?
Yeah, because name is in here.
Oh, I see. Yeah, but wait, don't we need to? This is a function, this null array. So
No,
we
don't.
need.
This layer is not a function.
It's a parser.
It's a
Never mind.
parser. Yeah, and now it is complaining about the precedence.
Aha.
Yeah, screw this.
Screwed. Okay, now it is complaining about. Oh man.
It's not a function, so you cannot fmap.
It's not a
Here.
function.
Oh.
No. But
Oh.
this is a.
Huh.
No,
we
wait.
Yeah,
This.
this needs to be a function.
No. Wait. There's something really wrong there. Let me
Yeah,
check how
so
the code was.
But it was a lambda, right?
yeah, so it was, but I added a lambda here, but then it's a parser.
Oh,
and
now
then,
I know what you did, Magenta. Now I know. Yeah. Oh, I see.
Oh,
try
I
try
see
making-
what is this. I
Then
see.
he tried to move the name to the left,
Yeah.
right?
But then
This
that's the
is
parser,
this.
right? So
Yeah,
You
so
have
that
to
was
pos-
precedence.
Okay, so
yeah.
what is. No, that is not precedence.
No, Magenta did the change because he thought that the lambda
Yeah.
extended all the way, as it usually does.
I forgot. Yes, I forgot it was like reading from the right, so it would pick the interface is actually on the parser first, and then it applies the thing on the F.
By the way, Magenta, that would only happen in Haskell because usually it has a lot lower precedence, the abstraction, right?
No,
In
I
other
think
languages.
wait, Lemos, I think it should still be name there because
No,
look at
it
what I did.
shouldn't. I'm.
No, but
Let's
wait.
test. Let's test.
No, but dude, look at what I did. Like, what is
Yeah, man.
this? And then you fmap to this.
Oh, no, because he's using some trickery on Haskell of like providing the
It
second
worked.
element to the tuple.
What
Yeah,
the-
yeah.
Yeah, let me explain to you, Magenta. So
He's doing
what?
partial application on the
So, yeah, this is a partial applied tuple.
Oh, this-
giving the second.
Yeah, because if you look at the lambda that you were doing, that I have it here. I looked at in the repo, and it is a pretty ugly lambda. Don't you agree? Look.
Yeah, that's also a pretty ugly syntax.
I'm not saying that I'm saying that the tuple is better. I'm not saying it's pretty.
Yeah, fair.
So instead of doing this lambda, you just use tuple sections, and it
then,
worked.
Like
Is that your
lambda,
prediction, Haskell? And
Is that
So
what?
wait, just a comma in a. Oh, I see. So you're partially applying the first.
Yes.
Right? Okay, makes sense.
What did you say, Nathan?
is that your prediction, Haskell? And
I'm not confident to say that a lot of people in production uses tuple sections. It is very useful because sometimes the lambda is so ugly and stuff.
yeah, but what I mean is, depending on
Pretty
what
useful,
kind of.
It's actually pretty useful to have this
No,
as a
it
constructor.
is. My question was like, depending on the company, you have to level the code base down, right? So
Code base down.
yeah, like what can I say? you use the simpler features because that way you guarantee that everyone, even the new ones, are okay in the code base, right?
I think I disagree with that. I think it takes
No, I
5.
said that places would do that. I
No,
didn't
it
say they
places.
should.
No. You're not saying that they should, but I think that if you decide to not use something that you can explain to a junior in 30 seconds, I think you're doing a bad decision.
Well, I certainly know
Yeah.
a person that would take a decision like this.
The question,
I'm pretty sure you know that person as well.
Lemos, but the question moves in the sense of sure, you can explain 30 seconds. Can the person understand in 30 seconds?
I
Then you
think.
say, but
Wait,
okay,
wait, wait.
are you the wrong person?
Yeah, wait. So you would say me that you have a Haskell junior that doesn't know what is partial application and he doesn't know about tuples.
Well, there are two things. He could know both and understand
Fire
right
up.
away what you did.
No. I'm not saying that you're gonna read these and magically understand it.
No, no. What I said is he could know tuples, partial application, have your explanation, and not understanding.
Yeah, then I don't understand. I don't see how the premises follow to the conclusion. You know tuples, you know type partial application, and you're applying to a Haskell job. And in 30 seconds,
Yeah,
if I say this is a
No,
lambda
then
to the first one, how that doesn't make sense, Nathan. I'm so
people.
I
sorry.
No,
would,
no,
I
no,
would,
no,
do,
no.
I would do the following. I would say, okay, there's this timer here. You have 5 minutes to understand this, otherwise you're fired, and that's it.
No,
Learning.
that's the thing. First about
No,
learning.
no. I
Look what
disagree with
is
that. I
obvious to
disagree with that,
you.
Mageta, because in 5 minutes you may not
No,
find
dude,
documentation about it.
no, dude. I'm just being. I'm not saying I would do this.
No one would do.
Yes,
No,
dude.
No,
if
no
Nobody.
if
one saying.
I would say that if you pick somebody to explain to me, 5 minutes is more than enough. I said 30 seconds
Dude,
because
I'm
I'm
just saying
assuming
that.
junior stuff.
I'm just saying this is something trivial, following the premises we took, which is like you know Haskell, you are a junior, and you know what's
Yeah,
powerful
there
applications.
is a problem with your guys' point on that. It's because what is obvious to me might not be obvious to you.
But man, you know Haskell. You are
No, no,
Haskell.
no.
You
I'm
apply for
only.
a Haskell job, man. What the heck?
No. Then
That
that's
doesn't
the
make sense,
thing.
dude.
Then that's the thing, man. The thing can move again. In the sense of, sure, then you could question what kind of people you are hiring, right?
Yes.
But without putting that question, the thing could be, man, what is obvious to one person is not to
No,
the
I
other.
agree,
And
dude. I
regarding you
agree.
not knowing that, dude, we don't know everything of the language we work with.
Nathan, I unfortunately can't understand how the premises follow to the conclusion. How you can say that a person knows X, Y, and Z, and then the conclusion doesn't follow because people have different standards of what is hard. That doesn't make sense. That is not. I can't understand the reason behind that. I'm so
Lemos,
sorry.
you know about AST, you know about types,
Just a sec.
and
Let's fix this type error and then we can move on.
Oh, it's still streaming.
Yeah.
Okay. It's gonna
oh,
be a very
it's
big.
3 hours and 3 on the stream.
Yeah, I think. Well, I'm gonna give you 5 minutes so as to try to debug this, and then I'm gonna finish the streaming.
Yeah, let's
But
see.
what is wrong there?
The the
Yeah,
the,
what's there?
the wrong. What is wrong is that I
You're
am
typing
using
the wrong
I
one.
tested both versions. The previous versions is still working, which
So why
without
you?
parameters.
Okay,
And
this is with a star on both.
yeah,
Okay, ENT.
then I'm passing to ABC. ABC is a function now that receives a person with these the string and the
Okay,
integer.
applying string and integer.
Yeah.
Uh,
And I'm passing using the type application syntax because now this is a type and not a
Are you
name.
pressing the correct order? Let's see. The first is the T, that is a string. Yeah, that's right. Yeah, the order is correct.
Okay, let's see how the ST version of the thing.
Wait. The error type is not nominal record? What?
It is. What do you mean? It is in nominal record.
No. Type error. Record type is not a nominal record. That was our error.
yeah, that's one.
Record
Where
type
are
is
you
not
launching this error?
record. Record type.
Not a nominal
Record type is not a nominal record, yeah.
250, yeah. 60.
That is on the.
Oh, I see.
It's a
This is the only
just
case in which we did the anonymous thing, right? And then after you type check, passing the fields to reutilize that logic, we type check to see if you got back an anonymous record, right?
wait. That branch is not there.
Oh, you're
It
correct.
is
You're correct. Sorry. Thank you, Magita.
it is on. It's not
It's in
found
the
on the
lookup.
record nominal record save files. So in the lookup, it can't find a nominal record.
Yeah. So it found something, but it
Yes, but
found.
it is not a
Oh,
nominal
it
record.
found a type of. It found the type abstraction. This is the type
Oh, I
abstraction.
Oh, because you are matching before like reducing.
yeah.
I
Makes
am
sense.
matching before reducing.
Yeah, if you reduce. No,
matching.
wait, he's reducing.
I am reducing before matching.
Wait, where are you
Branch
matching?
53.
I'm matching here.
And reducing at the same time.
I'm
No,
reducing
no, no,
first.
no. Take a look. The lookup returns you a type, right?
Oh, I
lookup
see. Yeah,
returns
he's not
me-
reducing the lookup.
Oh.
Yeah, makes sense.
Oh.
Yeah, I've just put a reduce there.
Wait, is that right? Ah,
Yeah.
No, reduce on 255, right, Lums?
you are looking up the name. What is the name? Where is the name coming from?
From the nominal record. I don't think that's gonna work.
Dude, we don't have the lookup anymore.
Wait, what?
We shouldn't have the lookup anymore.
Why?
Because the lookup was because you given it the name of the type. But now you are giving the type.
Makes
Oh.
sense.
Oh. Okay, so this is
Wait,
just this.
where are you getting the name to? How was this type checking? What was the name that you were getting?
Well, because
Inside the
T
key
nominal
nominal
record.
record.
Yeah, so this is just this you're saying, right?
I don't know, but let's
Yeah,
see.
we are reducing, and after reducing, we check if you have a nominal type. We do a lookup with the name, and that is wrong because
Yeah.
we already added to the alias context beforehand with the other stuff there.
Yeah,
we
check
can
if that's
just
a record.
we can just do this.
Yeah. Wait, how you do? Oh, that was my guitar, right?
Yeah.
Oh, holy shit, that was quite a keyboard move if that was you.
Okay, so we have one, two, one, two. Yeah, that is it.
With Emacs, I think that was possible.
No, with any editor if you configure, but I was surprised someone had that.
So T
Select this and delete the next line, like holding.
Wait. We have a problem. Because this doesn't make sense anymore, right? Because we don't have the name anymore.
What does the
So,
next one?
so is this only record? I think so.
Nominal record.
Wait, the record? Yes, okay.
Yeah.
Yeah, makes sense. Yeah, well, you could better match the name there, right? And get it.
Wait. That's that might be a problem. You remember the thing about we don't want to return and reduce it, man. We don't.
Yeah. So.
No, but we are not. Oh, we are. Ah.
Yeah.
Okay,
But
so
I don't know if you want the original T or the T prime. I don't know. Maybe it's T prime. What are you doing in other situations?
To me, it makes sense that prime because it's with the. Oh wait, no.
Take a look on the abstraction.
the abstraction.
There you are doing
That is where I'm going. Here. So what we do, we return the original before even doing after doing find placeholder.
Yeah,
It is.
as Magita said.
Okay, so it's gonna be type prime. Okay. Let's see.
It's very sure the thing will go okay.
Okay, so let's see what happens now. And it works. But we need to go back and check both versions. So I'm gonna remove this piece of code, put save in my Control C here. Yep, both versions work.
Awesome. That's it.
We have Nominal Records.
Well, until Nathan starts debugging and discovers 30 bugs.
Yeah. Okay, is this working fine? Yes! Congrats! Congrats, people. Nominal Records. I'm gonna end the stream now.